everybody, welcome to the only project that you need to secure your cloud engineering role, or if you also need to deploy your own SaaS application onto a cloud platform, then this project, it's really hands-on and really good for you. So without further much ado, let's see what we are going to build today. So we will be building a cloud native application with AWS. We are going to deploy our infrastructure onto AWS through infrastructure as code using CloudFormation, and then we will be using GitHub Action to run the automation flow. So it's going to be our CI/CD pipeline, so they call it. So you can do the same thing, and then you can master all the concept here, and then you will be rest assured to build this project for yourself or to secure the cloud engineering role that you need. Okay, so let's go to AWS. Let me show you what we have. So AWS, there's console, and then I will try to log in. So I will try and get my logins. Here, and then I would log in. Okay. So my password was wrong, so I'll get the right password and put it in here. Nice. So when we come to AWS, now we can see I do not have any resource created. So if you have an AWS account, first of all, to follow along with this project, you need to have an AWS account, okay? I'm looking forward to make one for GCP and Azure as well. But for now, we are focusing on AWS, so you need to create an AWS account. Let's go to CloudFormation, and then we can see I do not have anything here. We go to my EC2 instances, and I have zero EC2 instances running. So yeah, why not? Let's try and see what happens when we try to run a deployment. So I'll go to my deployment here, my CI/CD pipeline here, and then I will run deploy application. So we are going to deploy our cloud native application. So first of all, what our script is going to do is going to pick up our script and validate our CloudFormation stack. So it's validating. Let's see the logs. Nice. So once it's doing it, then we will also go to AWS and then go to CloudFormation. So once it begins to create the resources, then we will see how it is done. So yeah, the validation process is done. So now it move on to the deploy. Process. So now it's deploying our application stack using CloudFormation templates. Okay, so don't panic. The very first time I heard about CloudFormation, I was, this is very tedious. You know, I'm always used to Terraform, and now I needed to learn CloudFormation. But actually, after learning it, it's very powerful if you know how to use it. Okay, so let's see if our stacks have started creating. Now we can see that our stack have started creating. So it's going to create and deploy our application for us. It's going to build an application, build a database, and deploy our application using an application load balancer, so we can be able to access it on the internet. Okay, so it will take time. With the deployment. So without further much ado, I'm just going to go ahead and then we can start our project. Okay, so let's go to VS Code. Now we are in VS Code, so we need to have a project folder. Okay, so I will create one. I don't know what we should call it. Maybe you can leave a comment in the description down below what we should call our project. Okay, I'm going to call it CloudFormation Stack. CloudFormation Stack, and then I'll be able to open it here in my VS Code. So go to Documents, and then it is Tutorials and CloudFormation Stack. Okay, we are going to build our own project from ground up, okay? So you know how it is done. So first of all, I recommend doing the GitHub part first so that we can ensure that we can be able to run the same flow as I have done, because at the end of the day, you want much more automation, okay? So the first folder we need to create is something called .github. In order to use GitHub Action, you need a folder called .github, and then you need workflows. Nice. So inside workflows, then you can have many files that you want, okay? So we are going to have a file called deploy.yaml, okay? So I will go here, I will look for some code to copy. So let's go and say deploy.yaml. In here, in the workflow, we have deploy.yaml. Now, in order to start our GitHub action, let's first of all go to GitHub and also create our projects. So I will go to GitHub. Let me minimize this one so that you can see. So you can see one stack has been created. So we will leave it and then I will delete it and then we will take it from there, okay? So we go back to my GitHub and then I'll create a new project. So create a new project with me. If you don't know how to create a GitHub project, you just click on the plus button here and then select new repository and then give it a name. So we are going to give it a name CloudFormation. And you can choose to give it a description. I won't do this for now. CloudFormation stack. Okay, no space. Or I have to choose the owner. So I choose myself and then I'll create this project. CloudFormation stack. Nice. So we need to, let's go to our VS Code and then we need to push our first code to GitHub, okay? So I will also create a README file. Always need to create a README file for all your project, okay? README.md file. So we always need a README.md file. So we will just name it CloudFormation stack project, whatever name that you want, okay? And then first of all, let's push the code to our GitHub. I will close my codes here. So git add all files. Oh, Jesus Christ. Let's clear it. So git add dots for all files. Oh, we need to run git init first, okay? I don't know where my mind is today. So git init, first of all, we initialize git in our project and then git add all files and then git push, okay? So git branch -m and then I will say master, and then we have to add the repository, the remote repository, git remote add, and then again we also push it to the repository, okay? It is going to be, if you go to, let me minimize. So if you go to GitHub, you already have all those commands that you need to initialize your project with GitHub, okay? So it is going to be this one. So git push, and then we won't say main, but rather we say master. So spec ref did not match any of the push. We forgot a commit message. Okay. So we missed one step. So we initialize git add git commit -m, and then we will say project setup. Yes, git push master now. Okay, so git push origin, git push -u origin master. Then now we can push to GitHub successfully. Okay, so yeah, sometimes this can be very tricky, but yeah, once you keep on doing it, it will be very easy for you. Okay, so let's go to GitHub and see what's happening now. So we can see in GitHub we have our first file on GitHub. Okay, so our GitHub action did run, and then we got an error, so no event triggered. Nice one. Okay, so what do we need in a GitHub action file? You decide what is going to be in your GitHub action file. Okay, so we decide what is going to be in our GitHub action file. Now we can also see the AWS stack is creating all the resources. Nice. So let it create, and then we will delete it afterwards. Let's go back to our GitHub repo and then go back to VS Code. Go to VS Code. Nice. So what do we need in our deploy.yaml file? Okay, so inside our deploy.yaml file, we are going to just write some GitHub action code. Okay, so first of all, we need the name, and then we need on which actions that we are going to take. So name, and then we are going to say CloudFormation stack deployment. Now the next thing is we need on. So on which action should GitHub run this command? So on push command, and then on which branch? So we don't have main branch, but we have a master branch. Okay, so we have the name, and then the on attributes, then on push branch. Okay, we also want to add in the on pull requests. So on pull requests branches, and then we select the master branch. Now sorry about that. So now we also need to do some actions. So we will go for workflow dispatch. So workflow dispatch, and then with workflow dispatch, we are going for inputs. So this is the action that I did, that we are able to select deploy, because we will need one for deploy and we will need one for delete. So in case you want to delete your resources after creation, and I recommend we're going to delete after we are going to delete our resources after every creation, so that we don't get billed for it. Okay, but if you have money to throw away, then you can let it run a little bit more. Okay, so inside GitHub dispatch, then we will have actions. So we need an action. So I'll copy some commands here, and then I'll bring it here. So we need the action. So the action that we are going to take, we are going to add a description. What do you want to do? And then require true, and then we are going to give it the default deploy, and then type choice, and then the option is going to be, we are going to have two options. So we have one for deploy, and then we have one for destroy. Okay, it is going to come in handy later on. Now the next thing is we need to set the environment for the workflow dispatch as well. So you need to know a bit about YAML file. So I forgot to tell you about that, but probably if you are here, you are used to YAML file already. But for someone who don't know, remember your indentation is very important for a YAML file. Okay, so when you see this one, workflow dispatch, and then we have the inputs, which means this is an array, so it can contain many other things. Okay, so now we will come here again, and then environment. So now with the environment, we need environment. So the description, we need again the description, the required, the default, the type, and options. Again, I'm going to just paste some code here. So I believe we are done for now. So my indentation is wrong. I need to ensure that I get my indentation right. So it's going to be with the actions. So my indentation was wrong. I need to get my indentation right. So we go on the actions and then paste it here. Okay, nice. Mapping, same column. Let's do a quick fix. My indentation was wrong, so I will indent it correctly now. So like I just said, please remember your indentation. So with the environment tool, we are going to give it a description. Environment, environment to deploy, require true, and then the default is going to be dev, and then the type choices that we are going to select from is going to be dev and prod. Okay, so now the next thing we need to do is also set some environment variables for our GitHub action. It is very crucial to do this, because if you want to be able to refer the environment variables, then we need to be able to set them. So what I like to do, we need to put it on the same level as the workflow dispatch. Okay, so it's going to be env. We are going to have the environment variable, so env, and again the indentation is very key. Okay, again the indentation is very key. So I'll copy this one, and I don't know if I'm able to move them. I'll cut it and then I'll paste it here. Oh, yeah, let's indent it right. Okay, and then we'll be able to do it right, I guess. Again, we have problem with the indentation again. Okay, let's try and do a quick fix. Let's do a quick fix. So the indentation again is wrong, but again I believe we need to do it here env. Exactly, we need to do it here env, and then we can set in the variables here. Okay, so yeah, it's a bit tricky, but we will get it done either one way or the other. Okay, so I'll copy some variables here, and then I'll put it here. Yes, so what do we need? We need one for AWS region. The region that we are going to create our resource in is very crucial. And then we need the access key ID, and then again we also need one for the secret access key. Okay, so that we get all the permissions to create the resources on AWS. Okay, so if you go to AWS, you can create an IAM user and then be able to get the secret access key so that we can use it. Okay, I already have mine, so I would copy them and then I will show you what to do in the next field. But first of all, I want to ensure that our GitHub action workflow is intact so that we can move on to the next. So the next thing is the jobs, so it can stop nagging us about the error we have over there. Okay, so we need the jobs. So the first job we are going to have is to validate. So what are we going to validate? We are going to first of all validate our work. So the basic step we are going to do here is we are going to tell it on which system it is going to use. So we are going to select the Ubuntu latest, and then the next thing is we have to give it the steps. Okay, so in the jobs, you give it the name, and then you have the runs on defining the system that it needs to run on, and then you can define as many steps as you want. Okay, so always the first step is to check out the code, check out source code. Nice. And then we are going to use GitHub Actions checkout version 4. Okay, so if you don't know where to find this one, now our YAML file is clean. So for now, if you don't know where to find this one, go to GitHub Markets, GitHub Marketplace, yes. And then click on this link. Let me minimize my system here so you can see. Yes, so GitHub Marketplace, and then you'll be able to search for GitHub Actions or Actions. GitHub Actions. What was the name? Let's just copy it, and then you check out Actions. So it was checkout Actions. Okay, so I'll minimize it, and then I'll go to checkout Actions. Checkouts. So checkout, exactly. So if you go to checkout, then you can see. So even now we have version 6 now, okay, and I'm using version 4, which means I'm using the older version. So again, I'm going to just change it. Okay, so if you come here, you can see how they are using it. This is the documentation for how they are using it, so you can see how they are using it. Okay, so we have checkout with version 6 now, so I'm going to use checkout with version 6 now instead of using the older version. Now I will save my file, and we are done. For the first step, the first step is to configure the GitHub workflow. Okay, so let's run our commands: git add, git commit. Always give a good commit message. Okay, so initiated GitHub Actions workflow. Please always give good commit messages so that your teammates can know about what you did. Okay, and then git push. So now let's go to our GitHub action and then see what is happening in there. So let's go to our browser, minimize the VS Code so you can see my browser. Boom, now we can see we have successfully initiated a GitHub workflow. Nice. So that's all you need to do. So this is your first step in learning about CI/CD pipeline. Okay, it is all about automation. Okay, so now we can see that our system has completed. So now all I need is to get some command, and then so that let's see if we can get it. So it was application load balancer, application load balancer. Let's see what we have here. Application load balancer, load balancers. Now we have one here, and then let's see the endpoint so that we can visit it in the browser. I want the endpoint so we can visit it in the browser. So we have one here, and then the VPC is there. Let's go inside and then see if we have the target. Okay, so we should be able to see it from here, but I will get some code and then we will get it from the CLI. Okay, so let me get some code and then grab it from the CLI. So once I have my command here, I will just paste it here, and then it will just fetch me the output that we can visit. So yeah, this is it. So go to your browser. First of all, let's minimize our VS Code so you can see my screen. So I'll go here, and then we can see. Let's run it, and then let's see if our application was deployed successfully. Okay. We have problem. It should not be HTTPS. It is HTTP. Okay. Yes. So now, yes, we can see our application is running successfully. So now, with just one simple step, we are able to deploy our infrastructure and then also deploy our web application onto the infrastructure. Isn't this beautiful? Because imagine let's say if you have an application that you want to you want to create in peak hours and take it down when traffic is low, you can just use infrastructure as code through CloudFormation to just deploy your applications whenever you need it. Okay, so yeah, now that we see it is working, let's see how we can take it down. So I'll go back to my already made project. So go to the GitHub actions and then I will take it down. So let's go to actions and then let's try and take it down. So we are on the main branch, and then what do we want to do? Like we said, we want to destroy this time around, not deploy, destroy. And what do you want? Which environment do you want? Is it dev or is it production? Okay, so that's why we use the run actions. Okay, so I'll run workflow now. And now it's going to validate, and then it's going to destroy everything for us automatically. Okay, that is going to be very beautiful. So now that, let's go to CloudFormation and see what is happening there now. So now we can see delete in progress. So now that's it. So this is what we are going to have at the end of this project. Okay, so let's go back to the code and focus on getting it right. So before we start to code like a maniac, we first of all need to get one piece right. So let's go back to AWS so we can see it has been deleted successfully. So we'll go back to AWS and then go to IAM, identity and access management. So we need to, first of all, you need to create a user. You need to create a user and then create the security credentials for your user so that you can get the secret key and then secret access keys. Okay, this is very important for our project. So I believe it's this one. I have one for it. Secret key, last accessed. Yes, and then I have you can give it administrator access, but for this project I just give it administrator access. But when you are using it in your production stack, please remember to add all the permissions that you need. Okay, you can define all the permissions and then attach it to your user. Okay, so my security credentials, and then manage console access. No, okay, so yeah, access keys. I have access keys here. Yeah, access key and then the secret access key. Nice. So this is where you can create your access key as well. So you can create access key and then select command line interface and then follow the prompt. Just go to next, say you understand, and then go to next and then give a description and then just create it. Okay, I already have one, so I won't be creating more. So once you have those, we need to go into GitHub. So we'll go into our project. Let's find it here. So CloudFormation stack. So once we are in the CloudFormation stack, then we go to settings for the GitHub. So whatever the project is, ensure to go into the settings and then look for something called secrets and then select actions. Now we can see we do not have any secrets here. It's not this one, it's not environment secrets. Okay, it's repository secrets. But this is very useful because again, when you use this, you won't be able to see the values after you put after you fill in the blanks here. Okay, so I will copy my secret access keys and then use it here. So I won't be sharing this with you. I will take this off screen and then I will be back when I'm done. Okay, so first of all, let's use AWS region and then you say US East 1. Yeah, so yeah, this one you can see but not the rest. Okay, so US is 1, and then I will create my next variable. So my next variable is going to be AWS secret access key. And then the next one also is going to be The next one too is also going to be the secret access password. Okay, so where is my key? So I'll create again secret access key. We have the secret access key, and then the first one should be the secret access ID. Okay, secret access ID. I copied the wrong one to the wrong place. So secret access ID, and then the next one is also going to be the key. The next one is going to be the key. Yes, so once you are done, you should have one for AWS secret access key ID, and then you should have one for AWS secret AWS region, and then one for the secret access key. So basically we need this one so that we can do a lot of configuration onto our AWS resource. Okay, so if you're in an organization, then you need to define a user and then ensure to attach the policies and then use it in the secret key. Okay, so once we are done with that, we will move on to the next phase of our project here. So the next phase of our project is going to be doing the main work. Okay, so what are we going to do? Before we do anything else, we need to see the overall architecture. Okay, what we are going to build. This is very key. Don't just start coding. Okay, you need to take a step back. If you need to list it point by point, please list it point by point. If you need to draw it out by hand or using draw.io, you can use that to sketch out your architecture. Okay, I've already made an architecture already, so I will just go to my already made project and then I will show you the architecture so we can talk about it. So what we need to do is to first of all have an AWS account, which we do. And then on the AWS account, we are going to create a VPC. So a VPC is going to be a virtual private computer where we are going to create all our resources into. Okay, so you can, I believe with AWS you have access to create about 6 VPCs. So you can have a virtual private computer where you create all your resources into. So you have one virtual private A and then one virtual private B. But this project, we just need one VPC. Once we have the VPC, we also need an S3 bucket, and then we need a user. You know, the user is going to be you because you are the one who is going to put in the code with your colleagues. So once we have our S3 bucket, what do we need inside our VPC? First of all, we need to do the networking aspect. I know you don't like the networking, but yeah, we all didn't like it, but we still need to do it because if you don't get it right from onset, your whole architecture would not be meeting standard and be prone to security risks. Okay, so you just need to be able to do it right. So with the network, we need a public subnet. So we are going to have a public subnet, and then we are also going to have 2 private subnets. So 2 private subnet, one is going to be for our application subnet, and then another private subnet is also going to be the database subnet. Now, in the public subnet, we are going to have we are going to create 2 subnets. So we have public subnet B and then public subnet A. With the public subnet, they are going to handle the network, the NAT gateway. We will have NAT gateway A and then NAT gateway B. Why are we creating 2 resources into each subnet? Because we are trying to build a resilience architecture. So in case tomorrow if A is down, we should be able to use B. Okay, and then our application load balancer is going to live inside our public subnet. Now the private subnet is going to host our main application. So inside there we will have a subnet B and then a subnet A again for the application. So app subnet B, app subnet A. These subnets are going to host all our application, and then that is allowed to talk to the internet through the application load balancer. Once we do that, we also use auto scaling to spin out our EC2 instances. And then when we use auto scaling to spin out our instances, we will be using 2 instances at a go, because for resiliency sake, we need to ensure that we have two resources, depending on your criteria, how resilient you want your application to be. Then the next one is also going to be the private DB subnet. We are going to have DB subnet A, DB subnet B. This is where we are going to host our RDS database. Okay, so now the magic here is our DB subnet should always remain private and should not be allowed to talk to the internet. But our private subnets for the application level needs internet access. So in case we want to upgrade the server or talk to any third-party API, then we need to have internet access. Okay, but our database does not see the light of day for internet. If you do it like this, you protect your data, because securing data is very key in every system. If you don't secure your data, then I think, in my opinion, if you didn't build the application, then it's even much better. But you can also be wise to allow internet to the database, so that, let's say, your client side can talk to your database direct. But I won't recommend this. This is very bad design. Please don't do that. So let clients go through your web server, and your web server has access to talk to the database. Okay, so once we do that, the database is also going to use the secret manager, because we are going to have credentials, so we need to safeguard them in a secret manager. And then the next step is also we are going to do the logging of our application. Once we do all these steps, we are not done yet. We need to log our system, because every proper application comes with a login, so that you can always detect errors fast before your client even do. Okay, so let's say there has been a database pack, and then your CPU level is really high. You really need to scale up another database again, so you need to spin up another database again, or you need to spin up much more web servers to handle the traffic that you have at hand. Okay, so you can set your alert through SNS, and then we will use CloudWatch alarms. So whenever let's say we use our CPU of our systems to about 60%, we need alerts. We need maybe initial alert, and then when we reach about 75%, then we need to take some action. And all this action, again, you can automate it. You can also use API gateway to write more automation. Okay, so without further much ado, I believe this is it for now. So now having the whole overview is like a bird's eye view. Now that we have a bird's eye view, we need to go into our code to start to spin out this whole architecture. It is a lot, but I will do my best to try and make sense out of it. And if you're able to do this project and defend it, this is going to be good for you, and it is going to also speak well about you. Okay, so now we come to our code. The next thing we need to do is to create some folders here. Clear my terminal here, and then what is the next thing we need to create here? Let me access it here, and then we can say, okay, we need a folder called parameters. We need a folder called parameters, so we have to make a folder called parameters. So we will make one folder called parameters. I'll move it a little bit. So one folder is going to be called parameters. I'll come here, click on the plus folder here, and then say parameters. We create one for parameters. The parameters are going to hold the credentials for our system. Okay, so inside it we are going to have one for dev.json, and then we will have another one we have another one for prod.json. So it's just like managing your environment variable. So this is where we are going to manage it, so that we don't have to, let's say tomorrow we want to change something in our code again, then we need to go all the way inside our stack set to change values. This will be very tedious. Okay, so if you manage the environment variables in one file, then it's easy for us to access and change them all the time that we need. So I will copy some parameters and then I will paste it here, and then we will go through. So first of all we need is to define the environment. So the environment is going to be named parameter key. So the key is going to be parameter key environment name, and then the parameter value is going to be dev. So this is for a development environment, or you can have staging environment, whichever that you want. The next one is going to be a parameter key. We will have its template bucket name, and then its value is just going to be code janitor CNF templates. The next parameter is going to be for our database. So the database name is going to be appdb, and then the parameter key is going to be db username. The value of it is also going to be appadmin. Now we need to set the parameter key. The parameter key is going to be alert email, and then we can put the email of our choice here. So this is the email for your developer or whoever is going to administer your system. Okay, so your sysadmin. Now the next place is also going to be the parameter key. So this is where we enable HTTPS as well, but then the initial value is going to be false, because we are not going to add the complexity of HTTPS now, but we can look forward in upgrading the system much more later. Okay, so now let's focus on getting something done right. We will do the same for prod.json. So this one was for, it should have been for prod, but then it got to prod instead of dev. So now we go into prod, the same, and then the only value I need to change it is prod. Okay, so that is different for now. So if it's production level that you are going to do, then you have the production values here, and then this one contains our development value. So these are the development values that I've chosen, and then this is also the development values for the production level. Okay, so now that that is out of the way, we need to go on to the biggie. So the first thing is we need the template structure. So we need the template structure. So we need also another folder called templates, new folder, and then say templates, then I'll give it template structure, yes. Once we have our template structure, I like to keep my folders very neatly and organized, so I'm not just going to put everything in a junk file. You know, we need to also be able to have separation of concern. So tomorrow when something breaks in the ALB level, which is the application load balancer level, then we are going to know, okay, it is with the application load balancer. So that's where we need to do our debugging. Okay, so first of all, inside the template, the first thing we are going to do is with the network. So that is key. Remember, we need to create the VPC and then the private and public subnet, and then all the subnet we need inside those private and public subnet as well. Okay, so you have the network here, and then inside the network, then we are going to have what we will have here is also the network.yaml file. So we will create our first YAML file, network.yaml file. That is our first YAML file to deploy our CloudFormation stack. So what do we need? How do we define a CloudFormation stack? This is good. First of all, let me see if I'm able to move my screen a little bit. So now it's good. So the first thing we need to do to define a CloudFormation template. This is how we are going to define a CloudFormation template. First of all, you need the template version, which is going to be AWS template version. So you need to use this version 2010-0909. And then the next thing is the description. We need the description. Remember, it starts with capitals, okay? Description. And then we can give it the description that we want. So it's going to be CloudFormation template network, not this one. Network stack for CloudFormation stack. Nice. You can give it any name that you want, okay? And then the next one is going to be the parameters. So the parameters that we are going to use in this stack set. Parameters. The first one is going to be the environment name. We need the environment name. And then remember the indentation is very important, okay? So it's going to be type string. A type is going to be string. Description is going to be environments to deploy. Environment name is going to be environments to deploy, whatever description that you want to deploy, dev or prod. Good. Now, what is the default going to be? The default is going to be dev. So our default is going to be dev, and then the allowed values that we allow for the environment parameter is going to be dev and prod. Okay, so these are the values that we allow. The next parameter resource that we need is the VPC. So we need VPC. We need the VPC CDR. So we need the VPC CDR block. This is also going to contain all our IPs. So type is going to be string, and then description is going to be CDR block for VPC. I'll remove this one. Then the default IP that we are going to choose, default is going to be 10.0.0.0/16. Nice. The next aspect we need is also the public subnet CDR. So we define the public subnet A CDR. So we remember we need two public subnets so that we are building a resilience architecture. So public subnet A, and then the CIDR. So it type is going to be string, and then the description is going to be CDR block for public subnet A. So with the public subnet A, the IP for the public subnet A we are going to choose is 10.0.1.0/24. give us 250 IPs. And then the next one is going to be public subnet B CDR. It type is also going to be string. The description again is also going to be public subnet B, and then the default is going to also be default. It's also going to be 10.0.2 and then also 24. The next public subnet. Again, now we have public subnet A, public subnet B. Remember, when somebody asks you, why do you have two public subnets? Remember, it's for resiliency, for failover purposes, okay? So the next thing we create is private app subnet A. So we need also one for private app subnet A CDR. So type is also going to be string, and again the IP address for the private subnet A is going to be 10.0.11.0/24. The next one also is going to be private subnet B, and then the type is going to be string. Again, description, give it a description, and then the default value. It's very repetitive, but you need to do this, and when you do this once, you just maintain it over time, okay? So we have it IP is going to be 10.0.12.0/24, and then the next one is also going to be the private subnet for the database. So remember, we need private app subnet. This is where we are going to deploy our web applications into. So if it's our backend or client-side application, we are going to deploy all our application into the private subnet, and then for users to access our application, they need to go through the application load balancer. Okay, so when we get there, we also take time and give it a deep dive. Okay, so the next one is private DB subnet A CDR. Nice. It type is going to be string, description again, and then the default is going to be, so when you say the default, that is the default value that it will use. Okay, so 10.0.21.0/24. Remember, you can choose any IP you want, okay, but you just need this 4 octet notation. Okay, you just need 4 octet notation, that's all. The next is going to be, so we have for private DB subnet A. I hope you can see. Let me check and ensure that you can see. Yeah, you can see. So the next task is going to be with we need one with private, again remember capital letter first, private DB subnet BCDI block. That is going to be type string, and then the default value is also going to be 10.0.0.22.0/24. okay, it means we are going to get 250 IPs. Remember, you need to try and do this so that you can get the understanding. Don't just copy the code and then say you are done. Okay, it's a hard work. You need to go through it, try to get the understanding, and also remember to use ChatGPT if you need much more clarification on each step. Okay, so going forward, if there is anything that we need to get help from AI, we will just use ChatGPT to come fast. Okay, because I have coders that I build with, but usually to learn faster, it's much better when you do it one by one and then try to clarify whatever doesn't make sense for you. Okay, so the next area we will move on to is the resources. Remember, indentation is very key. The resources needs to be on the same level as this one. So those are the resources that we want to create. Now, these are the values that we are going to just refer to. These are the values that we are just going to refer to. But over here is the resources, that we want to create. Now, in order to create these resources, the first thing we need is the first resource that we are going to create is the VPC. So VPC. Inside the VPC, we will have one with type, and then the VPC type is going to be AWS. And this is how we call the resource. Okay, so if you have the AWS plugin installed in your VS Code, it will just suggest you the format. So colon EC2 colon. What we need is a VPC. It's suggested it for us here. What is going to be the properties for this VPC? So properties for this VPC are going to be, first of all, indentation is very key. Indentation is very key. So we need a CDR block, and then we are going to reference the so ref, and then there is going to be VPC CDR. Remember, again, this is where we defined it. Okay, since we use it, it's not giving us this warning sign. Okay, now we use this one, so the warning sign is gone. So the VPC CDR is going to be 10.0. Again, you see, now I made a mistake here, so it's good to say 10.0.0. So this is the whole network interface that we are defined, and then inside that we will have two subnets. Okay, so we have two subnets for the public facing, and then we have also two subnets for the application level facing, and then two subnets for the DB layer. Nice. So the next phase we will go on is the next property we will define is going to enable DNS support. True. So that we can use hostname. We can use hostname to talk to our applications. Okay, instead of relying on the IPs. The next thing we are going to do is also enable hostname again. Nice. So once we do this, then we have the possibility to use the hostname to communicate instead of relying on the IP. Okay, so because the IP could change and then the hostname never change. Okay, so the next thing you need to do is tags. This is very important. Please remember, tags are very, very important. If you want to be a good cloud engineer, you need to love your tags, because this gives you a vivid description of whatever you created, and also helps you in debugging processes as well. So the tag is going to be key, and then the value is name, but then the key and then value is going to be value is capital V. Okay, it's capital V. And then what is the value that we are going to refer here? So we are going to substitute the environment name and then append just VPC to it. So if the environment name is dev, then dev VPC. If the environment that we are deploying into is prod, then it is prod VPC. Okay, why this error? Yeah, we are not done yet, so yeah, probably that's why. Let's move on. Okay, length. Okay, let me try and see if I can fix this with just a quick fix. For now, we shouldn't see that, but sometimes when we are not done, it will just keep throwing out errors like that. No problem. So let's move on. The next phase is going to be yeah, you can see the error is gone. So yeah, there was actually nothing wrong. The next tag is going to be key, and then its value is projects. And then what is the value for this? The value is going to be CloudFormation deployment. That's it. The value is going to be CloudFormation deployment. That's it. The next thing we need to do, we need to define the internet gateway. So we need to define the internet gateway. Again, you make sure we are on the same level. So internet gateway. Again, why are we getting this error? Must start with a semicolon. Yeah, of course it does start with a semicolon. Let's try and give it a quick fix here because it shouldn't be like that. Okay, so what did we do wrong here? Sometimes my VS Code is acting very weird because there's actually no difference between these values. If anyone can see something, just mention it in the comment for me. Okay, now I see. Okay, because the indentation was wrong. Yeah, of course, like I keep saying, the indentation is very key. Okay, because if you do this manually, you are going to face all these problems. So it's all good. It's all part of the learning process. Okay, so the next thing is the type. You need to define the type. So with the type, you call again AWS ::EC2. So AWS ::EC2, and then we go to the internet. If you go to the CloudFormation for AWS, you'll be able to get all these references that we are using here. Okay, but because I've taken time to do it again, I'm not going to waste your precious time. So the next thing is internet gateway. That is what we need to use here. What are the properties going to be? Again, with every resource. So the next resource is internet gateway. Properties for this internet gateway. We are going to have a tag. The tag is going to be of a name, and then its value is going to be, again, the environment, and then internet gateway. So IGW, internet gateway for the abbreviation. Okay, the next thing is also the key for project, and then its value is CloudFormation deployment stack. Nice. What is the next resource we need to create? The next resource we need to create is attach internet gateway. We need to attach internet gateway. So again, the type is going to be of AWS EC2 VPC gateway attachment. And then the properties are going to be of we don't need the VPC ID here. The properties are just going to be of tags. Let's say tags, and then the name. So we have name, and then again environment, and then the internet gateway attachment, same for the project as well. That's good. Again, another error. How are we getting this error with this indentation? I'll take my time again. So tax. Okay. So we have for properties. Let me just try and copy and paste here. So we don't attach internet gateway. So for now, I'll just remove this one and then paste it here again. Yes. So we are just going to use the VPC gateway attachment, and then we will reference the VPC ID. So this is the VPC. What is the VPC ID? So we are just going to use the VPC ID that after we create the VPC, we will get the VPC ID, and then we will use it in the attachment. Good. So we will reference the VPC and then we take the ID. So the internet gateway is going to be attached to this VPC. Yeah, this is a very tedious part that we are fixing now, but we do it once and then we are done. The next part is going to be, the next resource is going to be public subnet A. So with public subnet A, so its type is going to be AWS EC2, and then the type is going to be subnet. Then the properties are going to be, so the VPC ID, again we need to reference the VPC ID. So the VPC ID is going to be ref and then VPC that we just created. Okay. The next property, remember again the indentation. Okay. This my auto indentation is very bad. So VPC ID, we will use VPC ID that we just created, and then the next property is going to be public subnet A. So we have VPC ID. We need the CDR block for this one. It's also going to be reference the public subnet CDR A, the one that we just created. So we reference the VPC CDR. So this one, public subnet A CDR, that's the one that we just created. Boom. So what more do we need here? We also need the availability zone. So with the availability zone, we are just going to select the first availability zone for this one. We are going to select the first availability zone for this one. Okay. So that is it. So the availability zone, we tell it to select the availability zone, the first one for this for public subnet A. Okay. So once that is also out of the way, we need to map public IP on launch. We set it to true. The next thing is to give it a tags. So the tags are key, name is there, and then the environment. We are going to replace this environment name, which we have already defined up there, as I've already shown you, with public subnet A. Okay, with public subnet A. Nice. We do the same for projects. The key is going to be environment. So which environment we have it, and then the environment name. and then another one for the tier. Let's give it a tag. We can give any tag that we want. Okay, tier is going to be public. So yeah, we're done. We are done with the public subnet A. Let's do one for B. So I will copy this one. We need to be smart, so we copy this one, and then we just paste the values here. Because we've already defined for A, we need one for B. So one for B. The subnet is the type is the same. The VPC ID is the same. The CDR block is not going to be the same. This is for B. Okay. And then the availability zone that we are going to select, because we've already selected the one for the first one for the public subnet A, we need the number one, we need the number two for, we need the number two availability zone for this public subnet. Okay, and then we also set the map on launch to true, and then we give again tags. So this is just B, and then the environment name, you grab the environment name the same, and then the tier is also going to be public. Nice. Now we need to define one for the private. Again, we need another resource for the private. So the next one is with the private app subnet. So remember, it's for private app subnet A. We need the type is also going to be the same, and then the properties we are also going to use also the same. Now the CDR block, we are going to reference the private app subnet A CDR block. Again, with the private subnet, we again select the first availability zone. So if you know a little bit about coding, then you need to know that the 0 index is just the first item in the list. Okay, so we select that one, and then we put the map to false, because this is private subnet. We don't want to map the public IP on launch. Okay, and then the tags, we just give the tags as well. So the tags, remember the tag, the indentation, the tags are going to be the same. So private app subnet A. Once my system sees that I've done the first few samples, then it can always help me do it fast. Okay, so the next one is also going to be the environment. Again, you give the environment name, and then the tier is also private. Nice. So nice, we are done. So this is going to be private app, so we give it, call it private app. The next thing we will do, let's see, the next resource that we are going to create again is the private app subnet. So private app subnet for B, the same, we do the same. Okay, the CDR block, you use the private app subnet B, which we already defined up here. Private app subnet B that we already defined up there. And then we will select the availability zone. We select the second availability zone. Again, in an array, the number 1 stands for the second item in the list. Okay, so map it also false, because this is a private subnet, and then give it the tags as well. Tags as well. Yes, private app. Nice one. So the next one, again, we need a private subnet for the database. So remember, we have a public subnet for our application load balancer, which is going to be internet facing, and then the private subnet for holding for deploying our applications, our web applications into that private subnet, which is the private app subnet, so the A and B. And then the next one we need also for the database. Okay, so we need one for database. So whenever you build an application, we need one for database and then one for the app service. The next one is app DB subnet A, and then the type EC2, and then we reference subnets, and then we will use the VPC ID. So we are creating it into this VPC ID. Okay, and now we will reference the availability zone again. So we select the first availability zone for the private DB subnet A, and then we will again put the map IP on launch to false. Then we will also give tags here as well. Here is going to be private DB. Nice one. Let's do one for the private DB subnet B. So again, we reference the CDR block that we already created here. So now we can see we've used all our CDR blocks here. Yes. So that's it. Availability zone, select the second one, map false, and then we give it the tags again. So yeah, speed is also very important these days. Whenever you build an application, remember speed is also very important these days. Now the next thing we need to do is to create a public route table. We are not done yet, so don't laugh, okay, or don't smile. We need to do more. So public routes table, so we need the route table. So we are going to use EC2 route table, reference EC2 route table. We will create this route table into this VPC, and then we will give it the tag. Yes, we will give it the tags here. Nice one. So the environment is going to be tier and then public. Yes, nice. So we have route table, public route table for our public facing subnets. We need another one. So public route, public default route. So the public default route is going to be public default route is going to be, we also use the depends on the, so for the public default route, for it to be created, we need to ensure that the attached internet gateway has been created before. So where did we define the attached internet gateway? So attached internet gateway must be created before we even reach down here, to defining our public default route. Okay, so what is it going to be? Public default route, the properties are going to be the public table ID. So this is the public table ID we just created up here. We need the default gateway for the public route. So we are referencing the public route table we just created here, and then we will say the destination to be all over the world. Okay, so all over the world, so it's 0.0.0/0. Okay, so our public internet, because we want people all over the world to be able to reach our application, so we need to allow that. Now the gateway ID, so gateway ID, the gateway ID will reference the internet gateway that we just created. So again, we created an internet gateway, which is here. So that is the value that we are referencing. We are referencing down here. Nice. So I'll move on to the next phase. Is going to be public subnet route association. So now we need to create the association as well. Public subnet route association. So public subnet route association. Nice. So it type is going to be type AWS EC2, and then we will use colon, okay, remember colon, AWS colon subnet route table association. Okay, so it's subnet route table association, and then route table ID is just going to be the public route table that we just created, and then the subnet ID that we are going to reference is the public subnet A ID. Okay, the next phase we need to do is do the same for the B as well. So we did for public subnet A route association, we need to associate the B as well. We need to associate for the B as well. Now we have done the association for the B as well here, just like we did for the A. So we again need an elastic IP for our system. So we need a NAT elastic IP. So NAT EIPA. So we need a NAT EIPA. We're going to get an elastic IP for our NAT gateway so that our private subnet for the application level can talk to the internet. So the internet can talk back to our private app subnet. Okay, it's very tricky, but take your time to understand it here. Whenever we are creating the application, we need internet for our app servers in the private app subnet. So we need to create a NAT, network address translation, elastic IP, elastic IP for the subnet A. So we will give it A here. You can give it whatever name you want here, okay, but this is how it works. So the type is going to be AWS EC2 and then elastic IP, and then it depends on internet gateway. The properties are going to be the domain VPC, and then we will give it the tags here. Very simple. Okay, very simple. Now if you do for whatever you do for A, you do for B. So if you have twins, you need to make sure that whatever you do for twin A, do the same for twin B. Okay, otherwise twin B will be sick. Please remember to take care of twin B also. So NAT EIP for twin B, and then again the same, depends on attached internet gateway, and then we won't use any address here, so just the tags. Give it the tags here, and then we are done. We are done for it. Nice. Now we need to define a NAT gateway for our subnet A. Now we define a NAT gateway for our subnet A. So the type is going to be AWS NAT gateway. We are going to use the NAT gateway, and then the properties are going to, we are going to get the attribute for the NAT EIP dot association ID dot allocation ID. So this one that we just created, we will get the allocation ID, then we will use it here for the allocation ID. Okay, then the subnet that it needs to be created into the public subnet A, and then again we will give the tags here. Remember, if you give twin B, if you give twin A food, give twin B food. Okay, do the same for the brother, which is the network, the NAT gateway for B. So we are done. We are done for this side. I believe we are done for the NAT gateway, but we are not all the way through yet. We need some for the private route table as well. So let's create private app route table A, so that we can route traffic in the private, at the private level as well. So private app route table A, then the type is going to be route table. So AWS EC2, then we use the route table. The properties, remember, are going to be referencing the VPC that we are going to use. VPC. Nice. Once we do that, let's give it the tags, and then we are done. So the tier is also private app. You can give as many tags as you want. Okay, and then we will do the same for private app route table B as well. Private app route table B, again, the type is going to be route table, and then the properties are going to be VPC ID. So which VPC we are going to use? So we need to reference the VPC that we just created. VPC, nice one, and then give it the tags. Nice one. So we are done for private app route table B. Now we need to create private app route A, and then private app route B. Okay, so a lot of networks that we are creating here, but we need to do all of it. Okay, so the next one is private app route table A. So private app route A. So AWS, we are going to use the EC2 route. So AWS, reference it by AWS EC2 and then route. And then what are the properties going to be? So the properties are going to be private route table A, and then the destination IP is going to be .0.0.0/0, so that we can get internet. Okay, now the next one is going to be the NAT gateway ID that we just created. So we reference the NAT gateway ID for A. The next thing we need to do is to create for B as well. So whatever we do for A, we do for B. Whatever we do for A, we do for B as well. Whatever we do for A, we do for B as well. So destination CDR block, and then the IP address. So destination CDR block, and then the IP address is going to be 0.0.0.0/0. So the NAT gateway ID is going to reference the NAT gateway B. So we did it for A, we do it for B. Okay, the next one we have to do is also private app subnet association. Okay, promise this is the last two we need to do, then we will be close to bringing it to an end. So we will do private app subnet route association, and then the type is going to be AWS EC2 private route table association. Nice one. What are the properties we can define here? So properties, and then we will say properties that we can define here. So it's going to be here, subnet ID, private app subnet A ID, and then route table is going to be private app route table A. Nice one. So we are done for private app subnet A route association. Again, do the same for B. Do the same for B. Nice. So we are done for B. And then we are done for B. So once we are done for B, then we need to we need to get the output. So outputs, this has been tedious. So we have to output it so we can reference them. Okay, so we are building stack upon stack upon stack. So always whenever we build anything, we are going to bring out the output. So the outputs, so VPC, when we create the VPC, we need to output it. So VPC ID, I will just copy and paste here so that I don't waste so much of your time. This video is going to be very long, so remember to get something to drink. Okay, so it's going to be the VPC ID, then we will say destination, the description is VPC ID, the net value is going to be the VPC we created. Now export name, then we are going to substitute the environment name. So if it's production or dev, then we use dev, and then the VPC ID, that's the name. So yeah, we are done for that one. Then the next thing we created was for public subnet. The next thing we created was for public subnet A ID. So we need to output that one as well, and then we will output it as dev, and then the name public subnet A ID. Nice. Let's do the same for B. Remember, whatever we do for A, we do the same for B. Okay, so if you give A $1, give B $1. Don't give B $2. Okay, give them the same. Otherwise, one will be jealous. It will be like Cain and Abel. I don't know if you know that story. It will be like Cain and Abel from the Bible. So the next thing is going to be, again, private app subnet. Private app subnet. So we will again indentation problem. Yes. Remember, indentation is very key. So let me make some space here so my code is nice. I like to make space. It's not about the niceness of the code, but it's about the functionality of it. Okay, so private app subnet A ID, but also remember the beauty is also part of it. They will tell you it's not about the nice of the code, but still, if the code is not nice, they will say, oh, your code is not nice. Remember to write nice code. Okay, so private app subnet A ID, we will also get it here, and then also we will do the same for the private app subnet B. Again, let's make the indentation right. Get the same for private DB subnet A. We get the same, then export the name. Now the next one is for DB subnet B. Also export the name here. Get the values out here. And then the next thing we need to do is also the internet gateway. We need to output its value because we will use it. Internet gateway, output the value here. This is how we output the value again. Get the description, the value, and then export the name. Okay, then the next one again will be for the NAT gateway. We need to export the NAT gateway as well. NAT gateway, let's export it as well. Let's export the NAT gateway as well. Export it. For NAT gateway B, do the same. NAT gateway B, ensure to do the same for NAT gateway B. NAT Gateway BID. And then we need the last two. This has been a lot of work. So now we will also go down here and paste it here. So the private app route table ID, we need to get that one as well. And then we need to get it for the table B. Okay, the route table B, we need to get that one as well. Then we are done. We are done with our work. We are almost done with our work here. So once we are done like this, then the next thing we need to do, we need to try and validate our work. Okay, we need to try and validate our work. So first of all, let's check the status. First of all, let's check the status. So clear my screen, and then this is how you check the status. So run this in the CLI, ensure you have AWS CLI already installed, and then configure AWS CLI. If you don't know how to do this, please comment in the description down below, and then I'll be sure to make a video about it. So AWS CloudFormation, you can also add ChatGPT for it. It will just give it to you fast. Okay, AWS CloudFormation describe stack. Then the stack name. Before we need to validate it, so we need the command to validate before we even move on to create it. Let me try and see if I can find a command to validate it so that we can use it. Yes, so now I got a command to validate it, so I will try and paste it here. So it is AWS CloudFormation validate -template. Okay, then we want to validate the body. So this is where we need to ensure we go into that file. Okay, so we need to ensure we are in that file. Okay, so before we do that, let me go out from here and then ensure we open a new terminal in the network folder, and then paste the code. All you need to do is to change the file here to network.yaml. so let's see. So no errors, so everything was done good. So if validation is done, then all we need to do is to create our resources now. So again, I will get the command to create the resource. Let me get the command to create a resource so that we can try and create it out. Yes. So in the same terminal, clear the screen. I have to make it bigger again so you can see. Clear the screen. Let me check if you are able to see. Yes, you are. So I will paste it here, and then to create it, we just say AWS CloudFormation update stack. Now we need the one to create the stack. Yes, so we just need the one to create a stack. So it's not going to be update because the resource does not exist, so we need to create it. So create stack. Let's see if it works. It seems to have worked. So now we have been able to create our network stack. Let's jump right into our browser to check our work out. So just go to CloudFormation, and then let's see what is happening. Boom. Now we can see it is creating our resource. So now we are creating our VPC and then the network stacks. So you have to give it some time while it does create. So this is the beauty of it. Now we will do it manually, and then going forward, I will show you so that whenever we finish every file, we will just push it to GitHub, and then our GitHub action is going to pick that code and then it will run it for us. Okay, so that is what we are going to do. So now that our resource has been created, let's go to AWS and verify our CloudFormation stack. So I'll minimize this one so you can see the browser, and then I have to sign in again. Let me get my credentials. So now I'm in again. So now we can see that in our CloudFormation stack, we have created our resource successfully. That is very good. That is very good for us. So now that we have created our VPC, so let's see if we go to the VPC. Let's see if we have our VPC there. So go to VPCs. Now we can see we have the default VPC, and then we have the VPC that we just created. So that is the dev VPC. So our network configuration is done. Elastic IPs. Then we have the dev NAT EIP, and then the dev NAT EIP also for A and B. So again, we have successfully created all the resources. Now that we've created it, we want to be able to take it all down again. So let's see if we can be able to take it all down again. I will get some command and then take it all down again. So first of all, let's try and work with ChatGPT so we can go fast. Okay, so these days you don't have to build alone. You have AI that you can work with. Okay, so I will go into my folders, and then I will look for give me the command to destroy the CloudFormation stack. Now we will just get the command, and then we will just run it fast. Okay, so we will copy this command and then go into our terminal, clear the screen, and then now I'll paste the command here. But remember, we just need to edit it. Okay, so it's AWS CloudFormation delete stack. Before we just need to do a lot of Google, and read a lot of Stack Overflow, but now with AI, everything is very fast for us. So once you keep on practicing and doing this by heart, then you will know them. Okay, so AWS CloudFormation delete stack -- and then the stack name. So what was the name that we just created for our stack? So if I go to CloudFormation, then we could see it is a multi-tier application that we have deployed. Okay, so stack name is going to be multi-tier application. Let's delete it. Boom. Now we've successfully deleted our CloudFormation stack. So let's see what is happening to our CloudFormation stack. Delete in progress. Nice. So this is going to tear down all the resources that we've created. So imagine if you have to create the VPCs, create all the network and then the subnet, and then now there is an update that you need to do. Now you need to go in one by one, find them and edit it, or you need to, if you need to take down your whole system, then now you need to find all the resources one by one and delete it. So isn't this beautiful to do and save you time? I would wager on this, because it takes time to build with infrastructure as code, but once you do it once, it becomes very easy for you. And then again, it's easy to maintain. And now when we use GitHub to also version our CloudFormation stack, again, now we have version control for our infrastructure as code. This is very beautiful if you can do this once and then spin it whenever you need it. Okay, so I would so the next thing we need to do is to create a path where we are going to put everything together. So we need one way that we are going to put everything together. Okay, so we need a file called, not in network but definitely in the root folder, we need a file called main.yaml. So we are going to wire everything together now. So now that we are going to wire everything together, again, we are going to define the resources. Let me try and see if I can move it a bit so you can see my screen well. Well, maybe you can see much better now, yeah? I hope it is clear for you to see now, maybe, or maybe not, or maybe it's too weird. Let me check it out. Maybe it's too weird. But I hope as it was before you could see. If you can't see, please let me know in the description so that I would take it down. Okay, so it was view and then zoom, appearance, and zoom out. Yeah, so now it's back to default again. So I hope you can see, but please let me know if you can't really see so that we can I can find a way around it. Okay, so let's move on to our next task. So the next task we need to do is to define the YAML for the main. So again, why are we going to do this? We are going to do this so it's easy for us to maintain. So separation of concern is very key for me. Whenever I'm building an application, I'm looking at separation of concern. I want each folder to contain a particular file. So let's say I have the folder for the network, and then I'll create my network resources in that folder. And then whenever something breaks in my application, then I know that if it's regarding networking, I'm looking for something in network file. Okay, so let's go to the main file and configure. So again, AWS template version, again 2010-09, and then the parameters, we set the parameters again. Now with the parameters, remember indentation, very important. So 3 spaces. Okay, so 1 2 spaces. Okay, so env environment name, and then we are going to, a type is going to be string, then the defaults we are going to set it to dev. Now we will allow only dev and production environment variables for now. Nice. What do we need next for our templates? So template bucket name, we are going to give it the type string, and again we give it the description. Now the default for, let me remove this resource, we don't need it. Now the default for the template, the bucket name is going to be CloudFormation, so short form CF template, and then bucket name. Okay, or probably I will just change it and then put my name there. You can put whatever name that you want there. Okay, I will change this one and put my name there. So code janitor CNF template, that's all. Now the next thing we need to do is to give the DB name. So we give the DB name, we are defining these parameters, and then we are going to use them going forward. Okay, so you can just define them. So DB name, and then the type is going to be string. The type is going to be string. The next one is going to be description, and then the name of RDS database name. That's all. We are going to reference it later, so we will need it. We need the DB username as well. DB username as well, type string, and then the description as well. So we can add no echo true, so no echo true. So because this is a DB username, we don't want to be able to output it, but for now we won't add it. Okay, if you are building in a production environment and you don't want to show your DB name, you can add no echo true. Okay, let me leave it for now. Okay, let's go. Now the next thing we need to do is we don't need the password, but we need the alert email. So alert email, this is going to be the type of string, and then the description is going to be the email address to receive CloudWatch alarms. Nice. Again, we are going to do enable HTTPS. So enable HTTPS. Its type is going to be string. Its type is going to be string, and then we give the description, and then the default is going to be false, not true. The default is going to be false because we are not configuring HTTPS yet. But if you are making it in production, and you need to add HTTP to your endpoint, so you need to configure it to true. Okay, but going forward in the future, that will be what we will be doing. Okay, so if you do all the work now, we won't have nothing to do in the future. So let's maintain it to false, and then we will fix it later. Okay, now allowed values are going to be true or false. The resources we are not yet to resource, so the next thing we need to do is SSL, because if you enable HTTPS, you need SSL certificate. SSL certificate ARN. Nice. The default is going to be empty because we don't have any SSL certificate yet. Nice. Then the next step we are going to do is to create our resources. So our main file is going to be the main orchestrator to handle the creation of all our resources. So we will give it resources, and then network. So network stack. The first thing we need to do is with the network stack. Okay, no, I didn't spell it right. So network stack, very important, get the spelling right. So type is going to be AWS. Again, how do we call the resources? So you start with AWS and then colon cloud CloudFormation and then stack. Okay, because it's the network stack that we are going to create here. So its properties, what is it going to have? Properties are going to be stack, and then the template URL, we are going to use a template URL. So template URL is going to be, we are going to substitute a string. Okay, so I'm going to copy it and paste it here. Yeah, so we need to do it right. Okay, let me move it a little bit. Right. So yeah, everything is correct, because if I enlarge it, then you can see it well. I hope you can still see. Yeah, I will check that error later. Okay, so you can see we have some error over there, but then everything seems to be fine for now with the network stack. Okay, so we are first of all going to upload our template stack into AWS S3 bucket. So first of all, we again also need to create an S3 bucket. So for instance, let's go to the browser and then let me minimize so you can see. So the delete was done, and then we don't have any CloudFormation stack now. Okay, so if you go to S3 bucket, for those who don't know how to create an S3 bucket, come to S3 bucket and then just create a bucket. Okay, you can just create a bucket. That is all. Create a bucket, give it whatever name you want. Remember, a bucket needs to be global and then it needs to be unique. Okay, because it's a global bucket name, so it needs to be unique. You can't just use anything. So you can use my name that I've used, so you have to choose your own. So yeah, that's it. So let's go back to our code. If you create the bucket, that was it. And then let's go back to our code. We can use it when you create your bucket as well. So I would go back to my code. So once we have that done, I will look at the parameters again. The resource for the network stack is again going to have parameters, so we need to give it parameters. Or also remember indentation. Okay, so parameters, and then its environment variable is going to be the environment name. So the environment name that we have set here, so the default is dev, so it is going to be dev. Now let's try and look at why are we getting an error with this one. So should be a value with allowed. Okay, allowed values, remove it. Maybe it needs to come down here. So why we get this error now? Let's try and give it a quick fix and see what's happening here. Okay, so apparently I did not add the quotation marks, so yeah, that's why. Remember your quotation marks, okay? Because this is very tricky. This can become a very big bug if you forget the quotation marks, okay? So it's very important to remember them. Yeah, because it's a string, we need to put it in a quotation mark, okay? You see, I forgot that, so remember, you need to be very attentive and open your eye, okay? So the next thing we need to do is the environment name. So now we will reference the environment name, which is going to be the default one we set here, the dev. That's it. Now we will go on to the next phase. So we are done with this one. Now we need a script that is going to help us load our file onto our S3 bucket. Okay, so now the next thing I would like us to do is to go back and then create another folder called scripts. So we need another folder called scripts. So let's create our new folder. We are going to call it scripts. It needs to be inside the root folder. Okay, scripts. And then we are just going to copy some script here. Okay, I will show you what they do. So we are going to have one for validate, validate.sh, and then one for deploy.sh, and again one for destroy.sh. Remember, when you learn how to do all this, when you take your time to do it, you will be able to talk to your interviewer about such a project that you've built during your interview to secure your your new found role. And if you're also building your SaaS application, you can use the same thing, because remember, I have deployed my own SaaS application that I use the same features, the same technologies here to build my own SaaS application. Okay, so remember, you can use this for your day-to-day production work. Okay, so destroy.sh is very important. You need to have that as well. So with the validation, I will copy some bash script and then I will put it here. So validate. So now all we are going to do is just to validate the template. Okay, so we use AWS CloudFormation template to just validate our main.yaml file. We validate that one, and then if everything checks out, we just need to output this, and then we run again this one as well. So if everything checks out, then we get the network.yaml is valid. So we are going to do one for the template. We are going to do one for the template security, and then the security.yaml file as well. We will do one for the ALB, we will do one for the secret, and then we will do one for the compute YAML. So we need to create all these files. So yeah, that's all we need to do for now. So now with the deploy, this is where we are going to load it to our S3 bucket. So instead of us typing the command one by one from the CLI, we are going to upload it to the S3 buckets from just a script file. Okay, so automation is very key. You need to learn how to do any task that you do it over and over. Please, if you can think about it to automate it, that will be better for you, okay, in the long run. So with the deploy file, the stack name is going to be multi-tier, and then the environment that we set, and then we give the param file. So we are going to configure the environment values from the JSON file. Okay, and then now we log the AWS account that we are going to deploy this to, and then the region, and this is the biggie. So to upload your files to AWS from the CLI, you need AWS S3 CP, which is for copy this local templates, so the file can be found inside the folder templates structure. And template structure, yes, we do have it, and then templates. No, so the file can be found within deployed here, so it's going to be found within the template structure network, and then the network.yaml file, and then inside S3 bucket we are going to put it inside a folder called we will have the template bucket, and then the folder is going to be templates, and then the file is going to be called network.yaml file. Okay, you can give whatever part that you want here. Okay, that's it. You do the same for the rest as well, and then now we deploy the application to our CloudFormation stack. So we on our AWS using the CloudFormation stack. Okay, so we will use AWS CloudFormation deploy, and then the stack name that we set up here. So stack name, and then we will have the template file. Is going to be the main.yaml file. That is where we are going to deploy from, and then the parameter overrides. Okay, and then we set the capability, and then we also give this value here. So fill no empty change set. That's all. We are done. We need also one for the destroy. You don't need to worry yourself about this one. If you copy this script and then put it in your script files, it will work perfectly. You can just change the values. Okay, you just have to change the values so it becomes yours. Okay, so yeah, that is it. So we will go through, and then we will echo. Now we are just going to do some logic here. So whilst everything is true, we are just going to ensure that we check the status, and then we can run the delete. Okay, so we can now run the delete. That's all. So I'll save this file, I'll save the validate file, and then exit out of those, because now their job is done. We don't need them for now. Let's move on to the next task that we need to do here. So we have the network stack done. We have the network level done. So if the network level is done, let's see if we can run the validate and check. So chmod +x, so let's give executable permission to, I need to go in that folder, so it will be easier for us to run it. Okay, open terminal in the script folder. So I hope you can see, let me bring it up. So chmod +x to give executable permission to the validate file. So once we do that, we need to run the script. So let's try and see if we can get the information from in order for me to look for it. Let's try and see if we can get it from ChatGPT file. So give me the command to validate my resources. So in ChatGPT now we can see we have, forget to minimize it so you can see. So now this is going to fetch us all the command that we are going to use to validate our template. So this is the same thing that is in our S3 is in our scripts, the script for validation. So now that we've given executable permission to our script, let's try and see if we can run it. So let's run that file. Okay, it's validate. So validate, let's run that file. Now we can see it's validating our template, and then now we have an error because we do not have the main .yaml. Okay, we do not have the main.yaml inside. We need to validate. So the file is main.yaml. So I will just copy my error message. First of all, I will list here, and then yes, because of where I'm validating from, my main.yaml is not here. So I'll cd back cd .. and then ls, and then I will copy my error here and then give it to ChatGPT. Let's get the error message so that we can fix it fast to take a moment. Yeah, so basically we just needed to go out, just like as I was saying, because we are not in can't find the main.yaml file, so we need to come to the root folder where we can find it. So let's run it again and see. Now it is validating our script for us. Boom. Now we can see the main.yaml is valid. Boom. The rest of the templates are not there yet. So okay, it found an error in the network.yaml. No such file or directory. Okay, so the folder structure is wrong for that. So what did we do wrong? Again, let's list it, and then let's list the folders in the template, and then let's get ChatGPT to help us fast. So get it. So ls, then we have the network over there, and then we will cut. No, I won't cut it. So let's first of all copy this one, and with the error message give to ChatGPT so that we can get the error. We can get it and then fix it fast. Okay. So remember also, in order to work hand in hand with the AI, let it help you. You need to know first of all what you are doing, and then be able to give it much more context so that it can help you, point you in the right direction. Otherwise, it's going to throw you around. Okay. So now your script is looking for this path, but the actual folder is also templates structure. So it's looking for template, not template. Okay, so what we can do is to go back to, oh, maybe you can see, so I need to minimize it. Yes, so ChatGPT is telling us that our script is looking for this part, okay, this file part. That is what is in our script, and then but our folder structure is template instead of template, so we need to change the name. So it's going to be template. Okay, rename and then template structure. That's all. Now let's try and validate again. Oh, now let's clear the screen. Let's try and validate again. Let's try and run the validating script again. So main.cml is good. Network.cml is also good. The rest are not created yet, so it gave an error, and then exit. Nice. So the next thing we need to do is to go and focus on the ALB. Okay, so the next thing we need to do is to go and focus on the ALB. Let's work with the ALB. So before we work with the ALB, let's first of all configure it in the main so that we have it. Network stack is done. Let's work with the ALB. So we are going to define another resource that we are going to use. So no, we will move on to the security stack. Okay, so now we are done with the network. So again, now that we are done with the network, we need to again come down to the security part, which is how we are going to secure our application at the application level as well, because now we have done all the security in the networking, but we still need to consider security at the app level as well. So at the security at the app level, we are going to restrict communication access to some of the resources. Most importantly, we need to allow the application load balancer, which is going to be the internet facing, talk to the how do we call it, the compute stack, because in the compute stack, that is where we are going to deploy our web service. So they need to communicate with the application load balancer. So clients will go through the application load balancer, and then we will direct them to the compute stack, where we will host all our EC2 instances. And then the database must not be allowed communication to the application load balancer level. Okay, so we are going to see it all in action. So if we go to let me minimize and then go to our GitHub and then see it in action for ourselves. So yeah, so the security configuration that we are going to do, we are going to allow internet access to the application load balancer. So the application load balancer, we are going to allow internet access there. So clients will go through the application load balancer, and then they will be routed to the application that we've deployed in the private subnet here, which is the EC2 instances that we have deployed through auto scaling. Nice. But then communication from the database to application level should be restricted, and then we need to enable communication between the database and the EC2 servers in the private subnet. Okay, so that is all we need to do. So let's go back to our code and let's get it done. Again, when you are learning this, it's a bit tedious, but try and try and go through it, okay? Because if this is your first cloud engineering project, you need to do it over and over again. Try to get the understanding for each step of the way, okay? So if you still don't understand something, please work hand in hand with ChatGPT. Make sure that you understand each of the context, okay? Ask why we are doing this, okay? So you can also be able to talk about this in whatever role that you are interviewed for, especially for cloud engineering roles or DevOps roles, okay? This is very key concept in cloud engineering roles and DevOps roles these days. So the network stack is done. We need the next stack we need the next one, which is going to be for security. So let's define our security. So to define our security, we are just going to give the stack. So security stack. So security stack, and then the type is going to be CloudFormation stack. Type is going to be CloudFormation stack, and then the property. So the property is going to be also not stack name, but rather template. Okay, we are going to use template URL, because we are going to load everything into the S3 bucket, and then it is going to pick it up from there, and then we will go. Okay, so substitutes. So it's just going to bear in mind to substitute the environment variable that we've defined here. Okay, so I will just copy this one. Remember, it's a string, so remember to copy it correctly so we don't get any errors. Now it is just going to be template, and then the file name is going to be security.yaml, or the only thing that needs to change is this one, the file, security.yaml. So that's it. So since we are done with the security stack, we need to go into our template and then create that stack. So we need a folder called security, and then we are going to call it security.yaml. That's it. So since we have already gone through creating the network stack, it's just going to be the same pattern that we are going to use. So I'm not going to bore you going through one by one again just to waste your time. Again, I'm just going to paste some code here, and then we will just run through them. Okay, so let's work from the top. So again, always when you are defining the template, you have to reference the version, and then we need the parameters again, so we set the same parameters as well. And then we, especially with this security one, we have the template bucket is stored in the S3 here, but then again the app port is going to be on port 80. We are going to use HTTP, okay, and then the database port is going to be port 5432, which is for Postgres SQL. Okay, now inside the security stack we have the ALB security group. So this is where we define the security group for the application load balancer. So it is going to allow ingress traffic. So ingress traffic is traffic coming in. Okay, so traffic from external coming in to our system. Traffic from external, look at it like a data center. So in a data center we have even with data center, I've thrown you away. Look at it like you have your web application. Now when you share your website with me, and then I am going to open that link, so I am the traffic coming in, so that is the ingress. So on which port should we allow a communication from your website from me? So it's going to be on port 80, and then it is going to it is going to port on the target port is also port 80, and then the CDR block is, we have to allow it from all over the world, so traffic can come from anywhere. And then the IP protocol is going to be TCP. Okay, so it is a TCP protocol that we are going to use for the IP. That's all. But remember, in an interview, someone will ask you, what is the communication protocol that you are using for your application load balancer? You have to talk about HTTP. Okay, you need to say if it is an HTTP communication or HTTPS communication. Okay, so that is it. And then also the API protocol, we do one for the HTTPS lesson on port 443. That's it. And then now for the security group egress, so traffic leaving our system. Okay, traffic leaving our system is called egress. Also the IP is 0, again, from all over the world, so we can access the internet. So allow all outbound traffic. That's all. Now we again give tags for the security for the A or B. It's very important to remember your tags. Okay, now we need to define security for the app security. The app security group is for your servers. That is the one your servers are going to use. So also ingress TCP from ports that we have defined already, and then to port that we have defined already. And then the security group egress, again, also allowed outbound traffic. Okay, now we give the tags here again, and then we do the same for the DB security group. So with the DB security group, we define the port as well, the from port as well, and then the security group ID that we are going to allow from. Okay, we are going to allow traffic from the security group ID of our server, not from the internet, of our server. Okay, the security group of our server, instead of IPs for our web service. We are just referencing the security group for our service. That is much way efficient. Okay, and then we also give the tags as well. Now we need to define a role. We need to define a role that we can assume for our EC2 web service. So the property is going to be a role assume role. So first of all, we define the assume role policy document, the version, and then the statement is to allow, and then we are going to just assume this role. Okay, now we will manage the policy ARNS, and then we also have to define the policies that we are going to allow. So we are going to allow our web servers to get the S3 bucket, so it can access our S3 bucket, so that it can access and run this user data. So when we are going to set up our web server, we are just going to be efficient and use the user data to set up our script. So from here, the next file that we need is the user data file in our scripts, which is going to contain some script to just install whatever we want on our web server on the first initiation of our EC2 instances. Okay, so whenever our EC2 instances are starting up, we want to prepare it, so by the time it's up, then it's ready. Okay, so that is why we are using the user data. That's all. And then the instance profile. So when we create the role, we have to use the instance profile to assume it. Okay, so when we are done, we just have to output the security group ID so we can use it, the app security group ID so we can use it, the DB security group ID so we can use it, then the role ARN, Amazon resource name, so that's what it means, Amazon resource name, so that we can use it, and then the instant profile name. Okay, so that we can use it as well. So I will save this one, and then like I said, the next file we need is the user data. So I need to get that and then put it back. So let's get let's get our script for user data. Okay, for now we don't have the script for the user data. Well, going forward we are just going to have it there, so you don't worry, I will find it and then we'll put it there. Okay, so I think I still need to find this user data so that we can use it. Okay, so first of all, let's create this folder also called the app folder, and then inside the app folder we are just going to have the user data. Okay, we could have put it in the script, but it's fine, it's fair enough. It's going to live in the app data, so we will load it into the script when we run it. So it's going to be user data dot sh user data dot sh. Let's rename it well, user data dot sh, and then I will just copy this Nginx code here for the HTTP Nginx. So yeah, we will have this one for our Nginx application, because we are just going to install an Nginx web server on our application, that's all. So this is what we are going to see whenever we visit our application. So app is running by CodeJanitor, that's all. We save it, and then we will close that file. So we are done for that. Close this one, and then we will now go back to the main file, and then we will do the next task that is required of us. So now that we are done with the security stack, we need to go on to the next stack that we need to create. But I can see that within the security stack we are missing something very crucial that we need to reference. So we've got the template right, but then again with the parameters we need to tell it the VPC that we are going to create in, so we have to give it parameters as well. Okay, so parameters, and then we are going to have the VPC. So we are going to get the attribute for the network stack, and then the output that we are outputting the value for the VPC. Okay, so that's what we are going to just reference. So this is one of the power of CloudFormation as well. So when you use it, you can create stack upon stack and then just reference them. So once we are done, we just also need the template bucket name for the parameter, as well, which is going to be the template bucket name, the variable that we just defined, and then the environment name as well. We also need to give the environment name as well. So the environment name, then reference the environment name. That's all. We need to do the same for also for the network. No, I don't think so, because we have to create the network first. Okay, we have to create a network first, and then that's it. We are done for the network, and then the security stack. We are all done. Let's move on. So in the main file, that's the only changes that we needed to add. Now that you've seen how we do it, it is going to be the same over and over for all the resources that we are going to create in the main file. Okay, so we will be a bit fast. So allow me to copy some script and then paste it here. So the next stack that we need to create is the application load balancer. So imagine when we have deployed multiple EC2 instances. If we don't have application load balancer, and then when traffic hits your site, it is going to be hard to distribute the traffic across your EC2 instance. So let's say if you have about 10,000 traffic at a time hitting your website, then only one EC2 instance is going to serve those 10,000 users. And imagine how smart it will be if those 10,000 users are served differently. So let's say 45,000 are served on one EC2 instance, and then the rest are also served on the rest of the EC2 instance. So that will be very powerful to do. Okay, so yeah, we will it is environment name. So the next stack is the ALB, so which is the application load balancer stack. Okay, remember when you go to an interview and someone asks you, so why did you choose to use an application load balancer instead of a network load balancer? Please always remember it is your decision to choose this based on the architecture that you are implementing, but preferably you would use network load balancer because that is cheaper. ALB is expensive, so based on your requirement criteria, okay, if you want to do a lot of configuration in the application level, then you can do that. But then you can also use network load balancer to distribute the traffic. Okay, so if you're able to distinguish between this, then you actually stand out at your interview. Okay, and again, you also need to know this so that whenever you are building your SaaS product or whenever you are building your own system, you make these technical decisions. Okay, so these are some of the decisions that you need to make on the job. Now, so for now, what is happening here? Okay. Isn't it beautiful? Okay, so let's go through. So we are going to have application load balancer. Its type is going to be CloudFormation stack because we create a resource, and then the properties that we are going to use. So it's going to use the templates from the S3 bucket, and then it will go to template and pick up the application load balancer that we have loaded into our S3 bucket from our script level. So yeah, it is beautiful. I can see I have a name error here, which means my environment name is wrong. I need to change it. I hope you did not make the same mistake as me, but if you did, please be nice to change it. Okay, environment name, not as spelled before. Okay, so our ref value was wrong, so we just need to correct that. Okay, so our ref value was wrong, which was the environment name. So now we change it, so we needed to correct that. So environment name, that's it. Once we have changed it to match, then that's it. Remember to just get the spelling right. Okay, so yeah, so once that is done with the application load balancer, we will access the template in this S3 bucket, and then the parameters that we are going to set, again the environment name, then the VPC that we created in the network stack that we are going to use, and then we are going to attach the public subnet A and then public subnet B to our application load balancer for resiliency. So that's why we are using two availability zones. Okay, so we have A and B for that, and also application security group ID. So ALB security group ID. So the security group ID that we created for the ALB, that's what we are going to use as well. And then enable HTTPS, which is going to reference our variable enable HTTPS. So if it is true, it is going to create HTTPS, but the default is false. And again, going forward, we can extend the project much further to handle HTTPS. Okay, and then also we add our SSL certificate here. That's all. Now the next, once we have done that, the next thing we need to do is to create the template for the ALB. Okay, so we need to create the template for the ALB. So if we go into our templates, then we can create one for ALB. Okay, so we say ALB, create a new folder, called ALB application load balancer. Let's make a template for it. Okay, so again, we are just going to go through the same as we have done before. So alb.yaml. Now I will just grab some code and then I'll put it here because we have done the first two, so going forward it should be fairly easy for you. Okay, so you can pause the video and try to go through with me as well. But again, it's just simple. It's just as we have done already. We have to keep repeating, so it's not nice to keep repeating yourself. So it's going to be the AWS template CloudFormation, AWS template formation version, and then format version, and then we give the description, the parameters again, the environment name, VPC ID, enable HTTPS, so we have enable HTTPS, we have true or false. So, but the default value is always false. Okay, and then the next thing we need to do is the SSL certificate ARN. So the SSL Amazon resource name that we will create if you want to connect HTTPS, but don't think about it, we'll do it later. We have to add public subnet A, which we already do here, and then also the public subnet B. Now we also get the ALB security group, and then the app port, then the default app port is 80. That's it. Again, the resource that we will just create. So we will create a load balancer. To create a load balancer, the resource we need is elastic load balancing v2 load balancer. That's all. Then the properties, we give the name and then the scheme. Now the type is going to be application, and then we also, it needs a security group, so we can add the security group to it. Now reference subnet, and then we can also add tags, which is very important. Remember, tags are very important for us to debug whenever something goes wrong. Okay, that's it. Then we get the app target group. We create the app target group resource as well. So basically we are just going to give the name and then the port. So the application that is going, the ALB is going to target, how it's going to talk to the applications. Okay, so the target type is going to be instance, and then the health check true, because it's going to always ensure that we check if our systems are always up. It's very, very handy to check this. Also, we will use this in the CloudWatch logs to monitor. Okay, so whenever system is down, you will just get alert and then you can fix it ASAP. Yep. Then again, the matches, when we are testing, the matches should be 200. So whenever we make the get request and then we can reach our system, then we are all good to go. Remember the tags again, and then the HTTP listener. So here we configure the HTTP listener for our application load balancer. That's it. Then the next one again, also HTTPS listener. We need to configure the HTTPS listener also for our application load balancer. So it port is also 443, and then the condition is going to use HTTPS, and then the protocol HTTP reference, the certificate, and then the SSL policy, which you can use this. Okay, now the default action is going to forward traffic from the HTTP to HTTPS. Okay, that's all. So the output, we also output the load balancer ARN, and then the load balancer DNS name, the load balancer target group ARN, and then listener ARN, and then HTTPS listener ARN as well, and then the load balancer full name, and then the target full name, target group full name as well. That's all. So this is what we are going to use. So that is done for ALB. So the next thing we need to do, once we are done for ALB, we need to move on to the next task. So the next task that we are going to do is around the compute stack. So we are going to deploy our web servers as well. So once we are done with that, we will deploy our web servers as well. Again, we will go back to the main file and then try and work our way from there. Okay, so now the next resource is the compute stack. So I will just again copy and paste so that we can go through fast, so I don't waste your time. So the compute stack is going to be the same. The type is going to be AWS CloudFormation stack. So when you create it once, you are just going to keep repeating it, and then over time what you will be doing with these files is you are just going to maintain it. So as these files are, you can use them as they are and then try to extend them to suit your needs. Okay, so we have the type, and then we get the properties as well. So now we're going to have it in the compute.yaml file. So everything is also going to be in the compute.yaml file. Now the parameters, again, we set the environment name, template bucket name, that's it. And then the private subnet ID, and then again the private subnet ID for the compute stack as well. And then the app security group, then the target group, and then the EC2 instance profile, so that we can assume role. Okay, so we will save it, and then we will go to create our compute stack. So the next file we need to create is with the compute stack. So if I go here, then now into the templates, then I'll go to create compute. Now we have to create the compute.yaml file. Compute.yaml. So we will do the same. So compute.yaml file. Inside the compute.yaml file, we define the AWS template format version for the CloudFormation, and then we will again define the parameters. So the parameters, we are going to have the environment name, and then next we will have the template bucket name, and then we will again have the private app subnet ID, one for the private app subnet B ID. So the first one is A, and then the next one is app security group ID, which we need. So in the app security group ID, you can also define SSH parameters if you need access to SSH into your AWS instance, so that you can do manual configuration. Then you can add your SSH certificate to it, so you can SSH into your web servers. Okay, so the next thing we need to do is also the target group ARN. The next environment variable is with the AWS EC2 instance profile name, and then the next target group again is also the instant type. So the next thing we do is with the instant type. So the type that we are going to create for our EC2 instance. So if you are creating an AWS EC2 instance from the browser, you have the possibility to choose between the types. Okay, so the allowed types for our instances are going to be a T2 micro. So based on your design architecture, you decide to go with a T2 micro or a T3 micro or a T3 small. Okay, for my production systems, I'm only using T3 small, and I pay around almost $70 to $75 a month for it, and I'm running 2 EC2 instances, and I think it's very cheap. Okay, so the next thing is with the resources. Again, define the resources. We've gone through it, so we have to define the app launch template. So on the app launch template, we have the launch template data. This is very important. So with the app launch template data, we have image ID. So if you go to AWS, you can get an image ID and then you can put it here. But to be smart and not to reference any ID directly, we can get the latest Amazon Linux machine ID, and then we can use it here. Okay, So the next thing we need to do is also the instant type. So we reference the instant type. Okay, so our default is a T3 micro. The next thing we need to do, reference the instant type, and then here we have the IAM instant profile. Okay, so the next thing again, we need to attach the security groups ID to our EC2 instances as well, and then the metadata option. So with the metadata options, HTTP tokens required, and then HTTP endpoint enabled. Then the next thing we need to do, very crucial, is for user data. So with the user data, we are going to have the function base 64, and then we will just substitute our values here, which we are going to use to create our web server. So by the time our web server will spin up, we want some commands to run, and then some setup to be ready made for us. So we're going to first of all update our web server, and then we will install AWS CLI on it. So once we install AWS CLI on it, then we have the permission to pull resources whenever we need. So that's why we define the instant profile, because all the permissions that we have defined in the IAM role, we attach it to the profile, and then the profile is attached to the EC2 instance, and then we can actually use all the AWS resources that we want. For instance, if we deploy our images into an Elastic container, we have the permission from our instant profile to be able to pull from Elastic containers. Okay, so when we deploy our Docker images into Elastic container, then you can pull those images from there. But in this one, we have AWS S3, so it's going to pull from S3 bucket. So we are going to copy from S3 bucket. We are going to copy from S3 bucket script, and then user data.sh. And then we will copy it into the temp file. So we will copy it into the temp folder, and then the file is going to be the user data.sh. Once we do that, we just need to give it executable permission. When we give it the executable permission, then we can just run it. So whenever our application is up, whenever our systems is up, then we have already what we have defined in the user data, which is to install an Nginx application onto the web server. It will be done automatically for us. We don't need to SSH into the web server to go and do all those manual configuration. Okay, so that's also one of the beauty of CloudFormation. So the tags, as always, tag specification, the tag specification. So we will have the resource type is going to be instance, and then we give the tags. Okay, very important, remember to do that. Now we need to create the auto scaling group. So once we create our EC2 instances, then we need to put them in an auto scaling group. That's all. So auto scaling group is going to be, we are going to use AWS, and then we will call the auto scaling group property, and then we will use auto scaling group. That's all. And then the properties are going to, we are going to create it into this VPC zone ID. So private app subnet A, private app subnet B. That's all, because our application is going to be in the private subnet. And then the min size 2 and then the max size 2, you define the resource that you need based on your requirement, but I suggest you do 2. Then the desired capacity is also going to be 2. So how many instances that we need to spin. So we are just going to spin 2 EC2 instances. That's all. So target group ARN, it's here also, we reference it here. And then the launch template, we also have the launch template as well. And then the version, we also get the version number here as well. That's all. Health check ELB, and then health check grace period is also 120. So whenever something fails, we just have to do a retry. Okay, so again, with the tags, remember your tags is very important to give the tag. Okay, now the output, we just output the launch template ID and then the auto scaling group name. That's all. We save this file, we go to the main. Now we are done with the compute stack. So if compute stack is done, then we need the secret stack. So the secret stack, its job is just going to hold the secret. Its job is just going to hold the secret for our resources. So especially for the database, you can define the secrets like the DB name, the DB password, and the app user or the DB user variables in the JSON file, but it's better to always keep them in a secret. So with database is very crucial. So we are very strict on how to secure database. So if you go into an interview and somebody asks you, so how do you secure your database credentials, the database login credentials, then you have to tell them you use Secret Manager to secure all your database credentials, because they would like to know, because nobody wants to work with a team member who would be prone to put database credentials in the code. It's very bad practice. Please don't do that. So all we need to do is the name that we give it, whichever name that you want. It can be anything that you want, but don't just say secret stack. It can be anything that you want. Okay, so the type is also going to be CloudFormation, and then the stack, and then it depends on the security stack. We need to ensure that the security stack is created before. We need to ensure that the security stack is created before we use it, and then the template is also going to be in this secret.yaml file in the S3 bucket, and then we give the parameters for this environment values. That's all. So that's all. Then once we do that, we need to go to template and also do justice to it. Okay, so if you go to template and then we go to the secret, so let's create secret. So template, and we don't have secret here, so we need to create secret. So secret, we create secrets, and then we would get some code and then put it here, and then let's go through them again. So secrets.yaml, there we paste it here. So again, define the version for CloudFormation stack, and then the parameters. So the parameters, we are going to have environment name, and then we have the DB name. So the database name, its default name is going to be appdb, and then the DB username is also going to be appadmin. That's all. Now with the resources, we are going to create a database secret. You can give it any name that you want. So the resources, you can give it any name that you want. So I chose to go with database secrets, and then we would use secrets manager to create a secret. Now the properties we are going to use, so its name is going to be the environment name, and then slash database, and then credentials. That's all. The description, we give the description, and then we are going to generate secret string. So we will generate a secret string for the username. So the username, we are just going to reference the username that we created there, and then the DB name, we're also going to use the DB name that we just referenced there. But then with the password, we are just going to let it generate a password string for us. So we will generate a string key, then value password, and then the password length needs to be 20. You can change it to 25. And then the exclusive variables that we don't want in our passwords are this one. So you can add more to it. You can add question marks, you can add equals to, anything that you want to it. Okay, now the tags, again, remember your tags, very important for debugging purposes. It's very key to do that. Also with the output, we just output the database secret ARN and then database secret name. That's all. So I will save it. Then we will move on to what we need to do. What do we need to do next? So if we have created secret resources, have we configured it in the stack? Yes, we have done that. So yes, we have done that. So yes, good job to us. So next we need to create the resource for the monitoring stack. Okay, so I promise you this is going to be the last one. Yeah, this is going to be the last one, I believe. So with the monitoring stack, we are just going to also create a monitoring stack, and then its template file is also going to be in the monitoring.yaml environment name, and then the output load balancer name is going to be reference this ALB output name, and then the target group full name, we are going to reference this one, and then the auto scaling, we are going to reference it as well, and then the alert email, so the alert email that we set in our JSON file. Okay, so let's go to create the template for it. So if we go, then we create, if we go to template, then we create a new folder called monitoring. Once we have created the monitoring file, then we can create the monitoring file. So monitoring.yaml. Then I'll paste the code here. So again, set the CloudFormation template version, set the parameters, so we get the name, the load balancer full name, the target group, auto scaling group name, alert email, and then the resources. We create alert topic. So first of all, with monitoring, we need to create alert topic. So you will create alert topic in SNS. We use SNS to create the alert topic, and then with the properties, the topic name is going to be maybe production -alerts -topic, and then the subscription is going to be protocol email, so we can have SMS as well. So subscription is going to be email, and then the endpoint alert email, which is the email that we have in the JSON file. So the next thing is to give it the tags, then we are done for that one. And then unhealthy host count alarms. So whenever there is an unhealthy host count alarms, we need alerts. Okay, so alarm name is going to be environment name, and then ALB unhealthy host. Then we give it a description, and then the namespace is going to be AWS application load balancer, elastic load balancer, and then the metric name is going to be a healthy host count. So the dimensions, we are going to have a load balancer, and then we are going to reference this load balancer name. So whenever a load balancer has an unhealthy alert, we need that. Okay, and then the target group as well. So which target group is going to be in. Then the statistics, we give it average, and then the period is going to be 60, and then the evaluation period is going to be 1. So again, we give the threshold as well for it. Now we give the alarm action. So whenever an alert happens, what do we want to do? Then we need to send alert topic. Okay, so we send an alert topic. Now we do the same for, now we've done one for host, we need to do one for CPU. So we always need to log our CPU usage. So imagine there is a database spike, and then your database has spiked up to 70%, and you do not get any alert for it, and maybe we are in Black Friday, and then people are visiting your site, you are getting a lot of orders, and then you do not take action when your CPU utilization has maxed out to 70%, going to 100%, and you still watch your EC2 instance to die. Because what happens is, when there is too much load on your system, then your system cannot serve the customers, so you'll be having a lot of bounce rates. It's not going to be good for you. Okay, so don't do that. So whenever you see your CPU alarm, you have to run to your AWS account to figure out what's going on, and then deploy a patch. Okay, now we define the properties. We give the property name, and then the alarm description as well. We give the namespace, then the metric, CPU utilization, then the dimension, auto scaling group name, and then we reference the name for that auto scaling group, statistic, again average, then period 300 seconds. So evaluation period 2, threshold 70. So threshold 70 is when your CPU max out to 70%, then you need an alert. Okay, same for the other one as well. So the comparison operator is going to be greater than threshold. So greater than, we need an alert. Greater than the 70, we need an alert. Okay, treat missing data, not breaching, alarm. So alarm actions, we send an SNS topic, that's all. Then output these ones. We output the alert topic, and then we output the unhealthy host count, then we output the CPU alarm name. That's all. Now we are done for this. We will save it. Let's go back to our main file. We have configured the monitoring already, so we are done for that. So monitoring is done. So once that monitoring is done, we need to go back to the main.yaml, and then again we need to go back to main.yaml, and then also output all the resources that we've created, okay, so that we can use them. So I will close this one, so we have a focus file to focus on. So that's done. Now we need to create an output. So again, I will get some code here, and then we'll paste it here. Don't worry about the error, I'll fix it, and then we'll move on. So the output, we are going to output the VPC ID, very important. So whenever you create, we need to output the VPC ID. Then we will move on to output the security group ID. Then we output the app security group ID as well, then the DB security group as well, then instant profile name, we will output that. Load balancer ARN, we will output that. Load balancer DNS name, we have to output that as well. And then the target group name, we have to output that as well. Auto scaling group name, we are going to again output this one as well. Launch template ID, we are going to output it for the compute stack. Then the database secret ARN, we are also going to output it. Now let me get a quick fix for this one. I'll get a quick fix for it, but it doesn't seem to work. No problem. So the next thing we need to do is the DB instance endpoint. So with the DB instance endpoint, we also have to output that as well. The DB instant port, we need to output that as well, and then the SNS topic, we are going to output that as well, okay. And then the unhealthy host count, we are going to output that, and then the high CPU alarm name, we are also going to output that as well. So I don't know why we are facing this error, but I will just copy this one so that we can use ChatGPT to solve it fast. So we go to our browser. Let me minimize it so you can see how we do. So we go to the browser, and then we will just paste our error message here. So we paste our error message here, and then we are just going to give it a sample of we are going to give it a sample of our main.yaml so that it has the context to look at to help us debug this, okay. So CloudFormation, and then I'll copy this main.yaml, and then I'll post it here. Now remember, you need to give it more context, so you have to tell it, let me know if you need more files for context, okay. But remember, whenever you have any file that contains private data, you don't need to share with the AI, okay. You need to edit those data before you share with the AI, okay. Private data, you need to be very private with them. So we just share with it, and then let's wait for the response. So once we are waiting for the response, you just need to remember, when you are able to do this once and for all, you are just going for skill. And this day and age, you have to work fast, okay. You have to work fast. So let it do its thing whilst we wait. So now it is telling us that we are referencing the database tag in the output, but it is there is no database stack resource defined. Okay, of course, if there is nothing defined, why should we find it? So what do we need to do? So I will copy my database. So which one is it? Yeah, so we don't have the database stack yet, so we need to do that. Did we define the database stack? I don't think we did, but again, don't worry, let's create our database stack. Okay, so let's create the folder, so database, and then we are just going to create the YAML for it. So database.yaml. We created the secret, but we did not create the database. So the database.yaml, we have it here as well. We set the parameters as well. So subnet A, subnet B for it, and then the database security group, database secret ARN, and then the database instance class. So when you are using RDS, then we also have the possibility to set the database instance class. So if it's going to be a T3 micro or a T3 small database instance. Okay, so yeah, so the next thing is define the resources database group, and then property, give the properties, give the tags, and then again we are going to use a PostgreSQL database. Now its properties, we are going to have the identifier, and then we give it the name here. The engine is going to be Postgres. So if it's MySQL you want to use, or your organization wants to use, you ensure to use the engine, the right type of engine, and then the engine version, the instance class, reference that, the allocation storage, and then we have the storage type, so GB3. Now we have storage encrypted. We need to put it to true. So whenever we encrypt our data at rest. Okay, public access accessibility. If you want me to access the database, then set it to true, but other than that, please set it to false. Okay, so the next thing is also multi-AZ, and then the database name. Now master username, we'll reference this environment variables, and then we'll also master user password. We need that variable. Then we reference it from the secret manager as well. So we get the username from the secret manager, we get the password also from the secret manager as well. So yeah, the VPC security group is also we are going to attach it to this, and then the DB security group name, then we give backup retention period, so 7 days. The deletion protection false. If you want deletion protection, then you turn it on. So next we give it the tags, and then again we give the output, so that our main.yaml file is not going to nag us anymore. Okay, so I believe we are done, so we should be done soon. Now that we've outputted, it's still nagging us. Let's try and get a quick fix. No, we don't need to delete it. We still need it, so we don't need to delete it. Database tab. It's not one of network stack security group. Okay. So again, I'll go to ChatGPT, and then I will minimize this one. Let's paste it here, and let's get it response. So I will just tell it to give us the correct file. Give us the correct files. So whenever you work a lot like this, when you code, you are just going to make these typos. Okay, so basically it's just a typo somewhere killing us. Okay, so we will just get the right files, and then we will just use it. Let's wait for the right files, and then we will just use it. Okay, Yes, so that is done. I will copy it and then I will replace our main.yml. Now we've replaced our main.yml, so we should be good. Yeah, we've replaced our main.yml, so now we should be good. Again, let's get a one for the database as well. Let's copy and place it in. Okay, we don't need that because we are already done, because yeah, our error is gone. So first of all, clear the screen. But whenever you copy the code, please remember to go through to match all the values that you have created. Don't just copy blindly, otherwise you would you might copy some shady code into your code base and then you mess things up. Okay, please be careful when you are using it. You know, I could also use my codex much better. Okay, yeah, much better. So if you also have codex, it's much better to use that. Okay, because I have installed codex in my system, in my VS Code, so I'm able to let it go through the code and then we will just fix it. Okay, so I have copied this one. I have errors in my main.yml. Let's fix it. So now it's just going to run through and then it will just fix it for us ASAP. Perfect. That's much better than copy one single file and giving it to ChatGPT. Okay, so these days software engineering is going to be much more competitive, because you see, an organization can just employ 2 people and then force them to work with extensively with AI so that they can develop and build applications faster, rather than trying to hire a whole set of teams. So if you are in the engineering field, you need to also man up your game. Okay, you need to be the person who knows how to integrate AI into your flows to make you work faster, so that you can always stand out. Okay, because the organization, they are not there to compensate you for lack of skills. You just need to bring good skills to the table and then that's it. Okay, so we are done. We need to now include the missing database tag. So the resources at the bottom of the get database and DB ports are valid now. Okay, I wired the existing nested stack output in main. Yes, so it wired it for us. Then that's it. I also added a depend on so that the database tag waits for its prerequisite. That's all. Good job. So what do we need to do? So now that we are done, we need to run our file. So now we are done, so we need to first of all run our file. So we will go to our project that we've created. Remember, when you fork or clone the project, please don't forget to give it a like and then also give it a star. Okay, I think it's star that we give here, not a like. Okay, don't forget to give it a star so that it can also reach much more people who also wants to learn and deploy their own systems. So let's first of all get the command that we need to validate, and then yeah, so where is our script here? So it is living here, so I would run the validation script. So script and then validate. Now it's just validating for us, so I will move it a bit up so you can see. So it is validating. I'll close this one. So remember, if you have ChatGPT Premium, you can use Codex. Many of my colleagues also love using Claude.ai, which is also very good. I don't have access to Claude.ai, but ChatGPT Codex is also working fine for me, so I can't complain. All templates are validated and successful. Now we can go full speed and deploy our application. So let's deploy. So again, if we validate, then we deploy. Okay, deploy, not destroy. Okay. Okay, so we need to chmod +x, and then we need to give executable permission to this. Now run the deploy. Nice one. So it is deploying our AWS resource. Let's log into our AWS resource. Let me minimize it so you can see. Again, let's log in, and then let me get my login credentials. Get my login credentials. And then now we will log in. So once we log in, we go to CloudFormation. Then we can see creation in progress. So it's going to take a very long time. It's going to take a very long time. So I'll be back when everything is done, okay? Not that one I need to open, is this one. So yeah, so it's going to take a very long time. So I'll be back when it's done. So you can also take a break, grab a coffee or grab something to drink, and then the next step I'm going to show you is to how to wire it into GitHub, so that whenever we deploy our application to GitHub, then it will just deploy for us. Okay, so see you in a moment. So now that we can see that our stack has been deployed successfully, let's go to CloudFormation and verify. I will have to log in again. I will copy my, where do I find it? I will copy my logins, and then I will log into my account. So yes, once I've logged into my account, now we can see in CloudFormation, we have our application created successfully. That is very good. If we go to application load balancer, yeah, let's go to EC2 services and look for load balancers, and see if we have the application load balancer that we can access. Load balancers. So when we come to EC2 and go to load balancer, then we can see that our load balancer has been created successfully. Now it's attached to this VPC, and then the availability zone that it chose. So yes, the DNS name record, this is the one we are going to use to access our application. So let's copy it and see. So let's go to the browser. Then let's try and visit this site. Probably it's going to go with HTTPS, so it won't work. I'll paste it now. You could see it's HTTPS. So now I have to remove the HTTPS, and then let's go with HTTP. Now we can see our application is running successfully. So app is running successfully. That's it. That's it. So now you can see with just a few commands, we're able to launch our infrastructure. Oh, I believe you couldn't see because I haven't minimized it. So yeah. So what I was doing was, you go to CloudFormation. No, if you go to EC2 instance and then go to load balancer, which is down here, load balancers. Now you can see your load balancer was created. So dev ALB, and then we will go into dev ALB. When you go into dev ALB, we can see the attached VPC, the availability zones that it is in, and then we will go into the HTTPS, and then we can see also we used HTTP. Nice. Okay, so let's go back to our ALB. Then we can see, let's find the one with the DNS record. DNS record. So DNS record. we can see the DNS record here. So we will copy it like this, and then we will go to the browser, make sure to put it here. So the first time you put it, it will direct you to HTTPS. So when it directs you to HTTPS, copy the link from the address bar and then paste it again. Then you can see it is HTTPS. So you need to remove the S and then run it again. Then you can see you can access your application. So this is the application that we have just built. So with just few commands, we are able to initiate our infrastructure, deploy our application into our infrastructure. This is very powerful. So moving on, we have to delete our stack, and then we will be able to do it through GitHub Actions. Okay, that is what we want to do. So in order to delete our stack, this is why we have the destroy.sh file, which is also going to handle all our distraction. So clear the screen, and then I will run it. I will run the scripts and then destroy file. Let's run it. Now it is going to destroy all our infrastructure. So it's validating, and then it will destroy it for us. So very, very good. We need to automate everything. Okay, to become a very good cloud engineer, you need to look at every task that you can do manually and try to automate it. Okay, it doesn't mean you're going to lose your job. It means that it frees you the space to think broad and increase your skills. Okay, you have to always try to find new strategies to implement. Okay, so you don't do the same thing over and over and over and over and again. Okay, this is how we grow. So let's go to the browser and see what is happening for our CloudFormation stack. I will have to minimize so that we can see. Let me minimize my VS Code. Yep. So if we go to the load balancer, go to CloudFormation, and then let's see what is happening. Okay, it's still not deleting yet. So what's happening here? I need to go into the destroy.sh. I need to see the command that we just deployed. So we went ahead to run the deploy script again. So that was not the command we want. Clear my screen. I want to destroy, not deploy, destroy. I need to give permission to this file, chmod +x, and then give executable permission to it. Now let's run it again. Invalid environment use. Dev. Yes, so now we are destroying. So let's check our CloudFormation stack and see what is happening. Boom. Now we can see the destroy process has initiated. So once that has initiated, we need to do it so that it will go through our let me minimize so we can see. So once we have run that code, let me close this tab so we can have a focus tabs. So once we have initiated those commands, then we can see in our CloudFormation stack that deleting has been initiated, and then it is deleting all our resources instead of finding them one by one to destroy them. That is powerful. Okay, so it's going to be even much more powerful when we are going to configure it to use GitHub Action. So whenever we make a patch to our CloudFormation stack, now it is going to trigger an action based on what we want it to do, and then it will either create or destroy for us. This is very powerful. Okay, so let's say you are working on your project and you have your master branch. So whenever the code comes into your master branch, then you need to either create or destroy. Okay, and then you can also configure it so that it's only senior developers that are allowed to deploy into the main or master branch, so that the destruction or the deployment can take effect. Okay, so let's go to our code, and then not my SaaS project. So let's go to our code. Now let the destroy do it, and please do not exit out of it, okay, because it needs to take time to destroy. So I will bring it all the way down, so you have a focus tab here as well. So we are done. Now we need to go back to our deploy.yaml file. This is where all the magic is going to happen now. So the first thing that we did for our deploy file was just the basic step to just check out the code. So in the validation step that we want, because first of all, whenever we've written code, we need to validate it, and then if everything passed, then we can move on to the following action. So with GitHub Actions or whatever tools that you are using to orchestrate your CI/CD pipeline, you can build in stages, okay? And then every stage is going to have a step, okay? So the first stage is going to be the validating stage. In the validating stage, we will have steps, okay? So that's it. That's, I think, the basic thing that you need to get in CI/CD pipeline is just the job. So the job is where you are going to run actions, and then in each job you are going to have stage, and then in each stage you just have steps. That's all, okay? It's not rocket science. So once we check the source code, now we need to configure AWS CLI on our GitHub server. So imagine it like this. Whenever GitHub checks out your code, when we set up a GitHub action workflow, it is like a computer that we are going to run commands from, but just automatically. It doesn't need human intervention. Now, when it doesn't need human intervention, remember that the command that we are running from my terminal here, I have access to my AWS access credentials through my AWS CLI. So I'm able to run commands from my local machine. We need to do the same. So imagine, take your local machine, put it in the cloud, let it work for you. That is all. Okay? That is all. So the next step is to configure AWS credentials. Configure AWS credentials. Name, configure AWS credentials. Nice. Now for the uses, the name, you need to give the name, and then what it's going to use. So the action that it is going to use. Go to GitHub Actions. So if we go to our browser, and then I will minimize. Again, you can find all this documentation, but because I have been doing this over and over, I just have my code that I can just reference. Okay, so GitHub Marketplace. Now, when you go to GitHub Marketplace, find AWS credentials, maybe. If you are looking for AWS credentials sample, you can configure AWS credentials. But AWS there are many providers that have done this for us, but then we can choose. I always like to choose the one from the service provider that I'm using, because you need to be sure that you are using the right resource so that you don't get any breaches into your system. Okay, so this is officially from AWS, so I would trust AWS to use it because already I have trusted them with my system already. So I would go to AWS and then I will see how we use configure AWS credentials. That's all. So now it's version 6, so I will get version 6. I will get version 6, and there we go. I will get version 6, and then we will paste it here. That's all. So we are using version 6 for AWS credential. Now that we have the version 6 in place, we need to go with and then with what are we going to use. So again, we need something called the AWS access key ID, the variables that we need. We need AWS access key ID, AWS access key ID, and then AWS secret access key, and then the region. Okay, so that's all we need to configure the AWS CLI credential onto our GitHub run server. Okay, so now it's we are referencing the secret and then AWS access key, but remember you need to configure the secret in your GitHub repo before you can access them. Okay, but we already did that, so we don't need to go back and do it. So remember, we also define the environment variables here, so that is why we define environment variables. So it is best to reference the environment variables instead of the secret key. So I would remove this one, and then we need to reference env.aws access key ID. That's it. Then again env, then AWS secret access key, again env AWS region. That's all. Save it. Now let's test it. Okay, let's open a new terminal. Our deleting is still in progress, so we won't stress about it. Let's open a new terminal in our root repo, push our code to GitHub, git add git commit. Yeah, I need to go out of this, clear the screen, git add every file, clear the screen, git commit, and then your message testing AWS CLI in run server. Yeah, let's give it like this, git push. Now let's go to our browser. Let's go to our GitHub repo and then check it out. So inside our GitHub repo, go to actions, and then let's see what is running. Now validation is in progress. Then now we can see the AWS credential pass. So it means that we were able to configure our AWS credentials successfully. Boom. Don't need to do anything more. Now you can do this step by step. So each step you just push the code to GitHub, see the error messages that you will get, and then you would build from there. It's not always going to be beautiful that whenever we push to GitHub will just pick it up, and then we will be so everything will go so smooth that we won't be getting errors. When you get errors, it's part of it. Okay, you need to like it, you need to love it. It's part of it. This is what makes you grow as an engineer. Okay, so if it's tricky, you can get your head around it. Don't stress too much. Use ChatGPT, go back and forth, try to understand the error and fix it. Okay, let's provide a patch for it. So we go back to our code again, not my SaaS project, deploy.yaml. So yes, I'll clear the screen. And then what we need to do is the next step. We need the next step. Okay, so the next step that we need, so whenever we have configured the AWS CLI, because this is the validation state, we need to also lint our code. Okay, so we need to check if the code meets code quality, so that somebody, you know, when you open compute, it doesn't match, you know, the indentation doesn't match. Everything needs to, like, code quality needs to be met before we can continue. Okay, if code quality is not met, then we need to fail our job. So the next thing is to install. So name, again, this is a step, this is an action within the step. Okay, so the next step is to what do we do? Install a package called CloudFormation lint. Okay, install a package called CNF lint. Okay, that is what we are going to install. So we will install it by running. So to install something, we use the run command, or to run any script or any command, we use this command. Okay, so when you use this pipe, then you can run many commands below here. Okay, you can run many commands. Okay, so we would run pip install cnf lint, pip install cnf lint, again git add git commit dash then cfn lint checking, git push it to GitHub. So this is just the only tutorial you need to master your GitHub action. Okay, with this you can build powerful systems with GitHub. So you can see it is running our action, then it is validating, and then it was going to lint our code for us. That's all. So we are going to install it, and then we will be using it to lint our code. That's all. It's done. Go back to let's go back to GitHub. No, you did not see the browser, so yeah, this is tricky. Yeah, I have to minimize so that you could see the action that it took place. So yeah, we could see we have, when we run, we have this commit message, and then its action has been run. So CNF lint checking. That's all. Simple. Whenever we push to the main branch, then it will pick it up and then run it. Nice. So what do we need to do next? So the next step, we need open it back again, and then the next step that we need is to validate it. So now we install it, we need to use it. Okay, so name validate CloudFormation template, validate CloudFormation template. That's all. Now run again, and remember I told you the pipe is to run many commands. So it is cnf lint, and then we will run the template. So I would say cnf lint main.yaml. So that's the main file that we want to lint. So GitHub will check out all your code into the server, so the server has your code. So cnf lint dash cnf lint and then main.yaml, and then the next thing is to validate all the template structure that we need. Okay, so it is CNF length, and then that where is our YAML files. Our YAML files are located inside the folder called template structure. So it is template structure, it goes into template structure, and every folder inside the template structure that has a YAML file, we need to lint it. So this is what it means. Every folder that has a YAML file, we need to lint it. That's all. Again, let's run the same GitHub commands and push it to GitHub, and then push, and then I'll clear my screen, minimize, go back to GitHub, and then we will see what is happening. So yes, so it will just install it, and then so in the future you can also add caching to it, so it doesn't need to install every time. Okay, so now we have an error. This is good. We have an error because our length is breaking, so we have an error here, which means we need to fix it. So we need to fix it. So we need to copy our code. I will copy this error message, go to my code, and then we are going to fix it. Okay, so I'll open my codex. Now I'll give it this error message because definitely there is some warning in the network stack, which is okay, but then we need to figure out this error. So we got error when we lint our code in our GitHub actions. So fix and tell me what went wrong. So we need to know. So let's give it a moment, let it do its job, and then we will see. So this is what I mean by after every stage, please try to validate. Okay, after every stage, try to validate. So if you don't have coders, use ChatGPT and then do the same as I am doing. Okay, so first of all, in the main.yaml file, so on line 90 there was an error. On line 90 there was an error. Yes, on line 90 there was an error that needed to be fixed. Database stack had explicitly dependency list. Okay, but the same dependency were already created implicitly. So CloudFormation automatically waits for resources referenced by get attributes. So CNF length raise a warning for it. Then okay, so basically it just fixed it for us. So let's try again and see if it is going to break. Git add, git commit. Remember, always give a good commit message. Okay, if I'm working with you and your commit messages are not good, I would really hate it. So let's check it out again. Let's wait whilst it does its thing. Install. Installation process, and then when it's done, we will want to see what happens in the validation stage. So in the validation stage, it is running. Now we can see everything is passing. Boom. So our problem is fixed. So now we can move on. Okay, so coding is just like, or engineering actually, how I see engineering is actually, it's like, you know, you need to be it's like a scientist. And in my opinion, a good scientist is the one that tries, makes error, break it, fix it, makes error, break it, fix it. So engineering is basically just try and error. try and error, try and error, try and error. You have to love try and error, because if you're a perfectionist person, this is going to be difficult for you. You want everything to be perfect, but how I see it is you need to try, because if you don't try and if something doesn't break, how do you know what you are doing even works? Me, I like to break it, okay? So if you want to work with me, you have to love breaking stuff, fixing it up, breaking stuff, fixing it up, because that's the only way we grow. You know, I know that in big corps, in big corporation, you need to, the politics are very high, but I thrive much better in an environment where we are allowed to break stuff and then fix it up, just break it, fix it up, but don't break it stupidly as well, okay? Just, you have to be mindful, okay? So I'll clear the screen, and then I would, you did not see the GitHub action, yes, so I'll minimize it, then you can see that we were able to pass it on this stage now. Yeah, so that's it. That was all that happened. We'll move on to the next phase. So after we validate, so CloudFormation stack, after we validate, then we need to run our main validation scripts. So now that we have successfully do the code quality, so code quality we did up there. So whenever you are running some steps, you need to think about code quality. So that's what we did, okay? So the next thing is name, and then we need to validate CloudFormation template. So now we are going to validate CloudFormation templates by running our real script. So it is just going to be run again, and then you can either give it the pipe, but if it is only one command, you just say scripts and then validate.sh. Now again, you can test git add git commit -m. It's tedious to do it, but just do it, please. Git commit -m, give the message, you just say validating AWS CloudFormation template. That's all. CFT, that's all. You can give it any abbreviation that you would like. Now we need to push it, and then let's minimize our code, go to our browser, check our actions, then we can see it has picked it up. Isn't this beautiful? Whenever we make a change, then it is picked up, then it will run it for us. And also, this is also much better for versioning of our CloudFormation template. So let's say tomorrow I am working with an engineer who is helping me with my my SaaS application, and then he did something with my infrastructure script, and then I can see that my servers are down. When I see that, I can just roll back to the previous commit so that I will have my infrastructure back, and then we can debug what went wrong, okay? But normally that's not how we do it. You have to go to staging, let us validate over there before we even go to production. We don't just deploy straight away into the main branch or into the master branch. Maybe in your own project you can do that, but I do not tolerate that. You need to go through the proper channels. You need to ensure that we pass through dev, and then we go through staging, where also some people would scrutinize it much better in a testing environment, and then you ensure that everything meets code quality, and then you put everything to the main branch, and then customers can use it, okay? And then they'll be happy after. Otherwise, you will get a lot of complaints. So that is done. We were able to validate our AWS CloudFormation. That's all. So if we're able to do that, go back to our code, not my SaaS projects. Go back to our code, And then the next step is going to be what? We need to deploy. So now we are done with step 1, which is validate. Step 2, what more do you want to do? Deploy. Maybe you have many steps that you want to go through based on your definition, but we just have to deploy in step 2. So deploy dev on push. That's all. Now this is where we are going to be tricky. Okay, so we are going to say, first of all, if we are going to use some command here, I will copy some code here and then I'll bring it here. So we will run some if command here. So if the event name is push and GitHub reference head is main, so whenever the event is push, GitHub, please listen. This is what you are telling GitHub. GitHub, please listen. Whenever the event is push and then it is into the main branch, then please perform these actions. Okay, that's all. But if it's staging, don't think about it. If it's staging, don't think about it. If it's dev, don't think about it. If it's testing, don't think about it. If it's QA, don't think about it. Okay, so we need, now we are also going to say before this will run, it needs to wait for validate. So you just use the name here. You just need this job name. Okay, that stage name. It needs to validate. So when we validate, then what do we say? We need to run it on the Ubuntu later. So that is the server it is going to use to run. So you are telling it to use the Ubuntu latest. You can use whatever you want, but we use Ubuntu latest. Okay, and then the steps for this job or this stage is going to be name, and then check out code. Always we need to check out the code. Okay, so we are going to use version 6 because we are using the latest one. Remember, we use the latest one, version 6. I would save it, and then the next thing we need to do, we check out the code. So if you check out the code, then what do you need to do? We need to configure AWS CLI. So now we did a duplication here. It's fair enough, but usually I would only configure the AWS when it's needed. Okay, so I won't remove it, but just so you know how it works. Okay, I will copy the same thing, bring it down here. Configure the AWS credentials for this this stage 2, which is the deploy phase. Now we configure the AWS CLI. Then what do we need to do? We need to run scripts because we have validated everything. You don't have to repeat ourselves again because otherwise it doesn't make sense to have 2 stages. Then now in the next step, we are going to give executable permission to the deploy scripts. Okay, so we'll run it and then we pipe. Now we are going to run for many commands. So first one is for the script deploy.sh, and then the next one is for the validate. So it's chmod +x / scripts and then validate.sh. That's all. Once we validate, what do we need to do? The next step is going to be run the validation script, because we need to validate again, because validation, I always like validations because it's very key for your system. Validate CloudFormation stack, and then run this validation script. So we give the executable permission, then we just run it on the server. That's all. Now when we finish that, please deploy name. So deploy CloudFormation stack, run this command. So we will run this command to deploy. So we are just going to run in dev. So let's say this is the production CI/CD pipeline. Then you say run this script, and then you add prod. Then the script will handle it for you. Okay, you don't need to do any job, just one time. Now we are done. But before I will push to GitHub, I just want us to finish this file so we can move on. Okay, so the next job we need to do, again, very important, to be on the same line. So 2 indentations, no, 2 indentations, yes. So now the next thing we need to do is deploy manual. So we need to deploy manual as well. So in case we want to deploy it manually, we can select it and run it. Okay, so in order for us to deploy manual, again, we need some if statement here. So whenever the event name is going to be workflows dispatch and the input action is deploy, then we would run again the same commands. We will run again the same commands that we've just written above there. So let's go through it. So it's going to be steps. Here is steps. Remember, it's steps. It's nothing else than steps. Okay, you can't give it any name that you want up there. It's steps, and it's not capital letter, it's small letter. Steps, and the name is going to be, we check out the code, configure AWS CLI, give executable permission, validate, and then deploy. That's it. So we would select the input environment. So that's why in the event we say the input environment is going to be either dev or prod. That's all. So we are just referencing that variable. That's all. We are done. We are almost done. I will save my file so I don't lose it if my computer crashes now. Now, destroying must be manual. It must not be automatic. Okay, please don't do that. You can do it, but you need to figure out how you are going to do it. This is where your architectural design has to come in place. Okay, this is how you envision it, and then you implement it. This is how I envision my system, and I implement it the way I want. Okay, so we need to destroy it, but as long as it's just like math. When I give you 5 minus 2, it is 2. 5 minus 2, it is 3. But then again, I can also say, to get the same answer 3, I will say 4 minus 1, then I also get 3. So we can again take different approach, but our answer needs to be 3, which means our answer needs to be the same. Okay, destroy manual, then I will just let it do it for me. So again, I'm very happy I have GitHub Actions, GitHub Code Pilot as well, which also monitors the way I code, and then I don't need to repeat myself again. So again, It's going to listen, and then when the action is destroy, boom, it's just going to run this destroy for us. Configure AWS CLI, run executable permission for the destroy file, and then run the destroy in that environment. I'll save it. Now let's push the code. So clear the screen in my terminal, git add, git commit -m, and then I'll say deploying CloudFormation stack. Git push. Now we push it to GitHub. Let's check out what is happening in our GitHub. I have to minimize my code so you can see the browser this time around. Yes, let's go. Deploying CloudFormation stack. Let's see what is happening. Boom. So this is the key. Now we have these manual jobs, and then the first stage is validate, and then the next stage is deploy dev on push. So that is why we use in the deploy stage. That's why we use the depends on. Okay, so I will open the code fast so we can be quick and then show you. So in the validate stage, we are done. Needs validate. It needs to wait for the validation to be done before this will run. Otherwise, when you don't do that, when validation is running, then deploy is also running simultaneously. Maybe you want that, but please don't do that. It's not good. We need to wait. So what is happening? So we are done. Deploy on dev push. Job was kept. Okay, job was kept. So let's go to our GitHub actions. Go to deployment, run dev, and then we select deploy. Then we select dev. Then we run it. Okay. Deploy manual. So let's wait for the validation to be done, and then let's see what happened, because it should have deployed our stack for us. It should have deployed our stack for us, but whatever way, if it is an error, we will figure it out, and then we will just fix it. Okay, so don't panic. These days you have to love errors. You don't have to panic. It's not like before you need to bend candles and sit with Stack Overflow and figure out what you did wrong in your coding. So now you can see. Now once the validation stage is done, this is what I'm talking about, baby. Once the validation stage is done, then we pick the deploy manual. Then it is deploying our stack for us. So you see, isn't this beautiful? Now it is deploying our stack for us. It is deploying our stack for us. So I would not my VS Code for my SaaS projects. Let's minimize it, and then I would refresh my stack. Now you can see it is creating. That is beautiful. That's all. Now let's go to our code and then ask my AI what went wrong when I push my code to GitHub. The deploy did not work. What went wrong in my GitHub actions file that when I put my code to GitHub, use the correct term, I push my code to GitHub, it did not run the deploy scripts. It's just skipped, but manual is working. So let's figure it out. Okay, Now it is inspecting for us. So I have my Inspector General of Commander Police inspecting my code files, and then it will give us a scanned report, and then we will see. Okay, so let's go to GitHub as it's working for us, as the AI is working for us. Let's go to minimize and go to the browser, and then we can see the deploy stack is deploying. It is deploying our stack. It is deploying our stack, so it's good. It's good. Now we have 2 resources in progress. One is ready, and then the rest is also upcoming. That's all. This is beautiful. This is beautiful. So I'll go to the code again. Please forgive me. I keep opening my SaaS projects, not to flex around, but only I don't do it intentionally. Okay, and I don't want to close it because I have a feature that I'm working on. So the deploy is okay. So in the deploy file, what went wrong? So the deploy job was kept. Let me open it big so that you can also see along with me. So the deploy job was kept because your workflow triggered and the job condition disagreed. Your workflow runs on push to master. So the branch was master, but the deploy job only allowed push to main. Yeah. So you see, these are some of the petty errors that I say. So this was push on master, but then we had main, so that was why. My god. So the ref head is main, so ref head is main, so that was where all the error came about. So go to job, we go to job, let's find it out. Okay, so we find it out. GitHub name dispatch, not manual, not deploy manual, but the real one, deploy on dev push. So it was here was main instead of master. Because it didn't find main, so it won't work. Okay, yes. So whenever you are able to push your code now, it should work. So now the AI has helped fix it, patch it now, and then we are done. So we get it. So please always remember, whenever it corrects your code, remember to review it. Okay, this is what good engineers do now. AI is not going to replace developers or engineers. It is only going to replace those who are refusing to work with it. I was refusing to work with it before. I didn't like that. It feels like I'm cheating. It feels like the power of my knowledge is being taken away from me. But no, actually, that's not what is happening. You need to scale faster. You need to work faster. You need to work faster, because now a job that used to take me like 2-3 weeks to do the job, now it's only a couple of hours max a day, and then I will be able to move that feature or move that project out of my way and then focus on other stuff that needs to push me forward. Okay, this is beautiful. So please don't also hate it. Just try to open your mind and learn with it. Okay, if you are not open-minded and you want to still hate it, it's also good. You can hate it, but we would adapt. Okay, those of us who adapt, we will keep going faster. So that is done. Let me close my codes. I'm done here. Now I have pushed the code to GitHub repo. So once this is done, you will have access to the same code files as well, and then you can use it. You can use it in your own SaaS application, modify it to suit your need. You can basically do anything that you want with it. I've given you the permission to do it. And then don't forget to give this project a star so it can reach many engineers also as well. Okay, and if you are watching this video, don't forget to give this video a like, and then comment so that we can always do better. Okay, just tell me what I do, what I did wrong, and then what I should also improve going forward. So you help me, I help you as well. Okay, if you have any project ideas that you think that you need help for me to make a video about, also please leave it down in the description or in the comment section. I always read them, so I can always pick it up and then make a video so we all can benefit. Okay, so without further much ado, I won't wait for this to be done, but as you can see, it is creating the resources and nothing else is going to happen. It is going to finish its job, and then when it finishes, all you can do is to remember to destroy it. But if you have money to spare, you can let it run for a day or 2 or 3 and then see the bill that AWS will throw at your way. Okay, so if you go to actions and then you go click on the CloudFormation stack, then you can see you have here to run the manual job. So on branch main master, then what do you want to do? I want to destroy. You select destroy, then just select dev. Okay, then run destroy, then it's going to destroy your work for you. So have a blessed day, and it's been a very long video. It's been a very, very long video, but yeah, that's what it is. See you in the next one.